the language that helps you to catch errors early and write cleaner code, making it easier to build and maintain JavaScript applications, is called TypeScript. Hello and welcome to another informative video from FED Learning. In this video, we will cover everything you need to know about TypeScript, from basics to advanced concept. This video is suitable for both beginners as well as experienced developers. The only requirement is you must have basic understanding of JavaScript. And by the end of this course, I am sure you will be able to use TypeScript to build large-scale applications. And if you wish to become proficient in TypeScript, then I request you to watch this video until the end. And if you are new to this channel, consider subscribing to FED Learning for more such informative content. So without further delay, let me take you through the agenda. And the first topic is introduction. Under this introduction, we will cover what is TypeScript, why should we use TypeScript, prerequisites for TypeScript. Also, we will do environment setup and we will run the first Hello World program using TypeScript. Next topic, we will see variable declarations. Under this, we will learn what is variable declarations and what are the rules we have to follow while declaring variable. Next topic is basic data types. Under this topic, we will learn type annotations and what are the different type of data types available in TypeScript, such as object, array, tuple, enum, union, and much more. Next, we will see control flow statements. Under this, we will talk on different types of loops, such as for loop, while loop, do while loop, if else, switch case, etc. Next, we will see functions. Under this, we will learn types of functions and different types of function parameters like optional parameters, default parameters, and rest parameters. Also, we will see the concept of function overloadings. Next topic I want to cover under this TypeScript tutorial, that is classes. So we'll talk on TypeScript classes, abstract classes, access modifiers, inheritance, and so on. Next topic I would like to cover is interfaces. Under this, we will learn about interfaces and extending interfaces. And after that, we will see advanced types. Under this, we will cover type guards as well as type assertions. And the last topic, we will learn about generics. Under this topic, we will see generic constraints, generic interfaces, and generic classes. So let's understand each topic one by one. So first, I'll talk on introduction. What is TypeScript? TypeScript is a free and open source high-level programming language developed by Microsoft in October 2012 that adds extra functionality to JavaScript. It means TypeScript is a JavaScript with extra features that make coding easier to read, easier to write, and easier to maintain. And the latest version of TypeScript is TypeScript 5.5 was released on June 2024. And next we can say TypeScript is a superset of JavaScript, which means any valid JavaScript code is also valid TypeScript code. Talking about extension, TypeScript files use the .ts extension rather than the .js extension of JavaScript files. And last, TypeScript has a significant drawback. It is not directly supported by browser, which only execute JavaScript. So in order to run TypeScript code, first we need to convert TypeScript code into JavaScript. TypeScript built on top of JavaScript. First, you write the TypeScript code, then you can compile TypeScript code into the plain JavaScript code using a TypeScript compiler. And then once you have a plain JavaScript code, you can deploy it to any environment that JavaScript runs. Next, we'll understand why should we use TypeScript. TypeScript is a superset of JavaScript which primarily provides optional static typing classes and interfaces. Next, TypeScript also implements the future features of JavaScript like ECMAScript updates, optional chaining, etc. And third, TypeScript adds type to the JavaScript and helps you to avoid potential bugs that occur at runtime. The TypeScript name implies that we can define the type of variable or a function. If not, TypeScript automatically defines the type based on the assigned value. And last, TypeScript is widely adopted in popular JavaScript frameworks such as Angular, React, Vue, Next, offering optional static typing and enhanced code maintainability. Now we will understand the difference between TypeScript and JavaScript. Basically, TypeScript and JavaScript are both programming language used for web development. But here we can find some differences. TypeScript is referred to as an object-oriented programming language. On the other hand, JavaScript is a prototype-based scripting language. Compiled language and interpreted language means TypeScript always points out the compilation error at the time of development. Because of this, getting runtime errors is less likely, whereas JavaScript is an interpreted language. The next difference is TypeScript has a feature known as a static typing, but JavaScript does not support this feature. On the other hand, JavaScript has a feature known as dynamic typing. And the last difference is TypeScript supports optional parameter, REST parameter, interfaces, generic, etc. Whereas JavaScript doesn't support optional parameter, REST parameter, interfaces, and so on. That we will see later. Next, let's understand the prerequisite for setting up the TypeScript environment. So there are 5 steps we need to follow to start with TypeScript. And first step is Node.js. Node.js is the environment in which you will run the TypeScript compiler. So, in order to install Node.js, go to the nodejs.org website and download the latest version of Node.js. And after download, you have to install the Node.js in your system, and you can check the version of Node.js with command node-version. Next, we need npm, Node Package Manager. So you don't need to install npm separately. It will install along with Node.js. So once you install Node.js, you can check the version of npm along with Node with command npm-version. Next, we need the TypeScript compiler. So for that, we need to hit command npm space install space -g space TypeScript. With this command, we can install the TypeScript compiler, and also you can check the version of TypeScript compiler with command tsc space -v. Next, we need a Visual Studio Code editor. So this Visual Studio Code editor supporting TypeScript and Visual Studio Code is highly recommended. However, you can use your favorite editor. So you can download Visual Studio Code from code.visualstudio.com website. And last, you need basic understanding of JavaScript if you want to learn TypeScript. So once you're done with the environment setup, you can create your first TypeScript program. So for that, first you need to create a new TypeScript file with .ts extension, and then type the tsc space file name command on the terminal to compile the file. For example, tsc space demo.file. This is your file name. And if everything is fine, you will see a new file called demo.js is generated by TypeScript compiler. And finally, type the node space file name command on the terminal to run the file, like node space demo.js, and you can see the output. Okay, so now I'll open Visual Studio Code editor and we will continue from there. So here inside Visual Studio Code, I'll open the terminal with Control plus backtick. And here, first we will check the version of Node, npm and TypeScript, because I have already installed Node.js and TypeScript in my system, and I am using the Visual Studio Code editor. Okay, so first I'll check the Node version. For that, I'll write node space -v. You can see the version 20.16.0. And now
I'll check the npm version with command npm space -v. You can see the version 9.6.7. And in order to install TypeScript, we need to hit command npm install -g for global and TypeScript. So with the help of this command, you can install TypeScript in your system. But I have already installed TypeScript in my system. So we can check the version of TypeScript with tsc space -v. And here you can see the version of TypeScript is 5.6.0. I'll just increase the font and now you can see. So it means our environment setup is ready to start with TypeScript. Okay. So I'll hide this terminal and I'll open the Explorer. And one more thing, if you are also using Visual Studio Code Editor, you can install the live server extension to speed up the development process. This live server extension allows you to launch a development local web server with the hot reload feature. To install the live server extension, click on this extension tab. To find the extension, type here live server and you need to click on the install button to install the live server. So I have already installed. That is why I can see the uninstall button. Okay. It means once you make any changes in your code and after saving it, the browser will auto refresh itself. No need to refresh the page. It updates automatically. Okay. Now we have everything to get started with learning TypeScript. So let's begin with a simple Hello World program. Here you can see I have already created one folder with name complete TypeScript and this folder will contain all the files for this tutorial. Now let's create a first TypeScript file with name demo.ts. Okay, and here I'll declare one variable with let message equals to hello world and I'll log this message. That's it. Okay. The next step is to compile this file to plain JavaScript using TypeScript compiler. Because in order to run the TypeScript code, first we need to convert it or compile it to the plain JavaScript code. And the command for compilation is tsc space file name. So I'll open terminal again, cls, and here I'll write command tsc followed by file name demo.ts and this .ts extension is optional. So this command creates a file demo.js which contains the transpiled code. So I'll hit enter and here you can see demo.js file has created and the variable declaration has modified from let to var. In .ts file, we have declared with let keyword and in demo.js file, it has modified with var keyword. Now the next step is to run the code and as of now, to run the code, we don't really need browser. We can make use of node with command node space file name. So here you can write node followed by file name. In our case, demo.js. Again, here extension is not mandatory. Hit enter and you can see the output hello world. So this is our first TypeScript program. But you notice we are getting an error in demo.ts file and you can see the error on over of this message and it is saying cannot declare block scope variable message. And it happens because TypeScript treats this file as a script rather than module. A module has its own scope, whereas a script share the global scope. In order to resolve this error, we need to add the export statement at the top, which exports nothing. So here I'll add export with empty curly braces. And by adding this export statement, TypeScript treats this file as a module instead of script. After that, let's compile this file again with tsc demo.ts. Before I hit enter, you can see the demo.js file there is no export statement. And once I hit enter, you can see the error has been resolved and also the changes are reflected in the demo.js file. But here, if you notice, after doing any changes in demo.ts file, we need to compile this file in order to run the JavaScript file. To skip this compilation step for every change, we can use command psc space file name demo space hyphen hyphen watch. So we can use this command to automatically recompile demo.ts changes. Okay, hit enter. And now here you can see the compilation is in watch mode. Now, if you do any changes on demo.ts file and save the changes, then compiler automatically creates a JavaScript file with new code changes. So what I'll do, I'll change this message with welcome to FAD learning. And now I'll save the changes. And inside demo.js file, you can see welcome to FAD learning. Because of that watch mode, it has automatically recompiled and the same change is reflected in demo.js file. Okay, now I'll open the another terminal and inside that I'll run this code with node space demo. And now you can see the output welcome to FAD learning. Okay, but this time we skipped the compilation step. Now, one more thing I wanted to show you. If you want to run this code on browser, then create one file with name index.html. With HTML template, I'll add here. And inside body, I'll add one script tag. And inside this script, I'll add demo.js file. And here I'll add one heading, complete TypeScript. Okay, so here we need to add the demo.js file because browser can understand only JavaScript, not TypeScript. I'll save the changes and I'll click on this go live option so that it will automatically run your code on browser. Here you can see complete TypeScript. Now I'll open the developer tool and here you can see we are getting error. Uncaught reference error, export is not defined. Okay, so as of now I'll comment this line and now save the changes and here you can see the output welcome to FAD learning. Okay, now I'll show you once you do any changes on this TypeScript file what will happen. Okay, here instead of this message I'll write another message. Please like, share and subscribe to FAD learning. Okay, I'll save these changes and now you can see after saving same file, the compiler will automatically modify .js file with new changes and once the JavaScript file updates, live server extension will auto refresh your browser. Now I'll open the browser. I'll comment this line and now here you can see the live server extension will auto refresh browser and we can see the updated message. So hope you understand. This time no more manual recompilation and browser refreshing needed for every change. Okay, so that's it for introduction. Now let's explore variable declarations in TypeScript. First we will cover the rules for declaring variable and then we will dive into keywords and variable scopes with practical examples. Okay, let's understand the rules first. Variable is a named place in memory where some value can be stored. According to the word variable, it can be said that the value of variable can be changed. So while declaring a variable, some rules have to be followed. Let me add the pointer here. So the first rule is variable name can't start with digit. And the second rule is variable names can contain alphabets, both uppercase as well as lowercase and digits also. So variable name may contain numbers or digit, but not at the beginning. And variable names can begin with any alphabet in lowercase or uppercase. Third rule is we can use underscore and dollar special character only. Apart from these, other special characters are not allowed. So let's understand this with an example. I'll open Visual Studio Code, and here for this strict mode, what I'll do, I'll delete this export, and here I'll create tsconfig file with command tsc hyphen hyphen init. So here you can see the tsconfig.js file is created, and here I'll search strict, and you can see strict equals to true. I'll comment this line so that we will not get any error while declaring variable. Okay, so let's understand the rules of variable declaration with an example. I'll comment this, and here first rule, I'll just add this. Okay, so here we will start writing examples. The first rule is variable name can't start with digit. So here, if I start var one emp name, so here you can say we are getting error because the first character is number. If I delete this one, you can see no error with variable name. But we can add the number in variable at last or middle, anywhere you can add, but not at the beginning. Okay, so this is our first rule. Second rule is variable names can contain alphabet, both uppercase and lowercase. So here I can write uppercase emp number like that, or I can start with lowercase like this. And our third rule is variable name can start with underscore or dollar emp name, yeah, or we can start the same name with dollar. Okay, but we can't write the variable name with other special character. Like if I start this variable name with hash, then you can see the error. Private identifiers are not allowed in variable declaration. So similarly, you can see with ampersand, yeah, we are getting error. But if we are using underscore and dollar, then we are not getting error. Okay. Also, we can't use the other special character in between variable name. Okay. Only two special character we can use while declaring variable. That is underscore and dollar symbol. That's it. Okay. So these three rules we need to follow while declaring variables. I'll comment this. And now moving to the next topic. What are the keywords we can use while declaring the variables? In TypeScript, we have three primary keywords for variable declaration, such as var, let, and const. JavaScript is based on ES5, means ECMAScript 2014. That is why in JavaScript we can declare variable with var keyword. And TypeScript based on ECMAScript 2015 or ES6. That's the reason in TypeScript we can declare variable with three ways like var, let, and const. So this var keyword is used to declare a variable in JavaScript, and a variable declared with var keyword is defined throughout the program. And this let and const, as I told, these two keywords are introduced in ES6. The let keyword is used to declare a local variable in TypeScript, and the const keyword has the same syntax as var and let to declare variables, and it is used to declare the constant variables. Next, we will see what are the ways to declare the variables. We can declare a variable using the let or const keyword, just like in JavaScript. However, TypeScript also allows you to specify a variable type using type annotations. So the TypeScript enhances variables with type annotations, making it a strongly typed language. When declaring a variable, you can specify its type explicitly. The first is let identifier, means variable name colon data type equals to value. It means we are declaring its type and value in one statement. second way is let identifier colon data type, which means we can declare its type but no value. In this case, the value of variable will be set to undefined. And third is where identifier equals to value. It means we are declaring its value but no data type. And in this case, the variable decide its data type by seeing its assigned value. And the last way is var identifier, means var variable name and semicolon. It says we are neither declaring its type nor value. In this case, the data type of the variable will be any and the variable will be initialized undefined. Okay, so let's move into Visual Studio Code to understand this with an example. Here I'll write comment. Here I'll write the first way of declaring a variable with type annotation. I'll write let my number with type number equals to 10. So here my number is a variable stores a value of a type integer and the value is 10. In the second way is declaring a variable without assigning a value. So let my number with type number semicolon. So here my number is a variable which can store only integer type data. But here you can see we didn't assign any value. So by default, its value set to undefined. I'll log this my number here and I'll run this project inside terminal with node demo. And here you can see the value is undefined. And if I log this my number, save the changes and I'll rerun this application, you can see the first console output is 10 and the second console is undefined. Okay, I'll comment this. And now let's understand the third way, that is declaring a variable without a type annotation. So here I'll declare let name equals to FAD learning. Here I'll add CName. Okay. So here while declaring variable, we are not specifying any data type. Therefore, compiler decides its data type as per assigned value. So in this case, FAD learning is a string. Then the data type of this CName variable is string. And again, we will console this with CName and you can see the output. Console. Control C. You can see the output FAD learning. Okay. Now the last way is declaring a variable without a type annotation and value. So it's simply I'll write let city. City is a variable name. And in this case, we are not specifying data type as well as we are not specifying any value. Then compiler takes its data type as any and its value is set to undefined by default. So I'll again log this cls node space demo, enter, and you can see the output undefined. So with the help of these four ways, we can declare the variables in TypeScript. And also I want to show you how to declare variable with array and object. So here I'll take first example with array. Let fruits array. I'll use data type string with array equals to, here we can add the string values inside array. Banana, mango, orange, semicolon. That's it. So I log this fruits array, save the changes, and I'll rerun the application. And you can see the output with array of value banana, mango, and orange. So similarly, you can create a variable with type object. Imply object. Here we need to open and close one curly braces. And inside that, so I'll add name with type string. And I also want to add the age as a key with type number. So inside this curly braces, we need to add a keys or properties which we need for this object. And then equals to, we need to write one more open and close curly braces, and inside that we can write the key value pair. So name equals to John inside string, comma. Next property is age, colon 30. Let's log this object, employee object, comment this line, save the changes and rerun the application with node space demo. And here you can see the object name equals to John and age equals to 30. So this is same like JavaScript. Okay. Last, we will see the example with const keyword. So here I'll write the constant variable with type annotation. Const pi with type number equals to 3.14. So in this case, we can't change the value of pi variable because it's a constant variable. So once you assign value to const variable, you cannot change it. So use this const for such a value that should remain constant throughout the program. Okay. Here you can see if I change the value of this variable 2, 3, 4, anything, you can see the error cannot assign to pi because it's a constant. And instead of this, if I assign this pi variable with var keyword number 1, 2, 3, and if I want to change the value of pi equals to 555, then I can change that value. So with var keyword, I can easily change the value of variable, but with const, I can't change. So this is the difference between const and other variable like let and var. So I'll comment this code. Okay, so I'll go back to PPT. And now next we will learn variable scopes in TypeScript. Here, scope means the visibility of variable, and the scope defines that we are able to access the variable or not. And here you can see that TypeScript variables can be of local scope, global scope, or class scope. So what is mean by local scope? As the name suggests, local variables are declared within the construct like methods, loops, etc. And local variables are accessible only within the construct where they are declared. Next is global scope. Global scope variables are declared outside the programming construct. These variables can be accessed from anywhere within your code. And last is class scope. If a variable is declared inside the class, then we can access that variable within the class only. So these are the definitions of local scope, global scope, and class scope. Let's understand this with an example. So in this demo.ts file, you can see I have commented everything. And here I'll create one variable var with name global var of type string equals to like. So this is my global variable. I can access this variable anywhere in this program. Okay. So next I'll write here one function with name sub, and inside that I'll declare one more variable with name local var of type string equals to subscribe. Okay. So this is my local variable and this is my global variable. As I told, this global variable I can access anywhere in the program, but this local variable I can access only within this block or function. For more understanding, I'll log this local variable inside this function as well as outside this function. Okay. And also I'll log this global variable outside as well as inside function. Okay. Now I'll save the changes and I'll rerun this file with node space demo. So we are getting output undefined and like. In order to see the output of these two console, we need to call the function. So I'll call function here, and after that I'll add one more log with message outside function. Okay, save the changes, and here I'll rerun this application and you can see now the output. Here I'll minimize this screen. Okay, now here you can see I have called this sub function first and then I have written this console outside function, and after outside function you can see the output of these two consoles. Okay, so This subscribe and like is the output of these two console, line number 41 and 42. After that, outside function, and then 47 and 48. That is undefined and like. So you can see, so this first local variable, we can access the value of the subscribe inside function, but we can't access the value of local variable outside the function. That is why this line number 47 console is displaying undefined. Now, if you talk on global variable, you can see that we can access the value of global variable inside function as well as outside function. And you can see the value. This like is for line number 42 and this like is for line number 48. It means the global variables can be accessed from anywhere within your code, and local variables are accessible only within the function where they are declared. Okay. So now we'll see the last scope, that is class scope. For that, I'll create one class here with name ABC, open and close curly braces. And here I'll declare one more variable with name comment with type string equals to share your comments. Okay. So now this is the class variable, or else I'll write the name class var. Okay. So this class variable are also called as fields. So fields are declared within the class but outside the method. It means if we write any method here like sum, so here inside I'll declare variable A and B, and I'll store the addition of these two variable in variable C, A plus B. Okay, you can see this is the method, and the class variable are declared within the class but outside the methods. And these variable can be accessed using the object of the class. Okay, so in order to access the class variable, I need to create the object. So I'll create object with let keyword, let obj equals to new abc. Now I'll log this with obj dot class var. Now I'll save the changes and I'll rerun the application, and you can see the output. Share your comments. Okay. So this is all about class scope. So we have seen the rules to declare variables, keywords, ways to declare variables, and variable scopes under the variable declarations. Now let's proceed to the next fundamental concept of TypeScript, that is basic data types. Under this, first we will see what is type annotations. TypeScript uses type annotations to specify explicit types for identifiers such as variables, functions, objects, etc. This explicit type is a type assignment in TypeScript. When creating a variable, there are two main ways TypeScript assigns a type. Like I'll show you with an example. I'll comment this previous code. And here, the first way to assign type, that is let fname of type string equals to John. This is called as explicit type. In this example, we are assigning the type explicitly. That is why this example comes under explicit type. Next is implicit. So here, fname2, I'll remove this type, and instead of John, I'll write Bob. So in this example, we didn't assign a type, so it comes under implicit type. And in this implicit type, compiler will assign the type as per our assigned value. So we have assigned the string value. So compiler will consider the fname2 is a string type value. It means we can say implicit assignment forces TypeScript to infer the value. So this explicit type assignment are easier to read and more intentional, and this implicit type of assignment are shorter, faster to type, and often used when developing and testing. Okay, so coming back to type annotation. So it means type annotations are used to enforce type checking. It is not mandatory in TypeScript to use type annotations. However, type annotations helps the compiler in checking types and helps avoid errors dealing with data types. So here we can understand type annotation with these three examples. One is simple variable, second is with function, and third is with object. You can see in this example, age is a variable, and here we are assigning type explicitly as a number. And in the second example, here is a display function, and we are passing two parameters. One is ID and another is name. And here also we have added the type explicitly, ID as a number and name as a string. And in the third example, this is the object, and inside this curly braces, we are passing the properties like ID as a number and name as a string. And then we are assigning the value to the same object, that is employee equals to ID equals to number 100 and name equals to string with name John. So here inside employee, we can't pass the value as a string to this ID. Similarly, we can't pass the Boolean or numeric value to this name. We have to pass the string value to this name, and we have to pass the number value to ID because we have given the data types to this ID and name is number and string. So it means once an identifier is annotated with a type, it can be used as that type only. If the identifier is used as a different type, the TypeScript compiler will throw an error. Okay. Next, we will see the data types. What are the basic data types available in TypeScript? When you create a variable, you are planning to give it a value. But what kind of value it can hold, that depends on a variable's data type. So the first data type is any. Any is a special data type. Also, we can say any is a super data type of all data types. If a variable is declared with any data type, then any type of value can be assigned to that variable. Let's understand this with an example. So here what I'll do, I'll create new file with name datatypes.ts. And here I'll declare one variable, let first of type any equals to 1, 2, 3. Okay. It means with this any data type, we can assign any value to that variable. Like if I want to assign the string value to the same variable, then I can assign that value. Like Bob, we are not getting any error. Similarly, we can assign the Boolean value to the same variable. True. We are not getting any error. Okay. And if I log the first variable and you can see the value, it will change. Okay. Save the changes. And here compile this project in watch mode with command tsc hyphen hyphen watch. And you can see the compilation in watch mode. And also you can see the data types.js file is generated. Okay. I'll open the another terminal. And here I'll run this file with command node space data types. And you can see the output 1, 2, 3, then Bob, then true. It means we can assign the different types of data to the any type variable. I'll open the PPT again. And here you can see built-in data types and user-defined data types comes under any data type because the any data type is a super type of all data types. So now, what is built-in data types? Built-in data types are also called as primary or primitive data types. And built-in data types are those data types that can be directly used by the programmer to declare and store different variables in a program. And built-in data types include number, string, boolean, null, undefined, etc. Whereas apart from this built-in data types, user can also define its own data types, that is called as user-defined data types. And that includes enumerations, means enums, array, tuples, classes, interface, and functions. Now first, let's see what are the data types comes under built-in data types. So here you can see first is a number data type. It represents a numeric values. Next, string is used to represent a sequence of character. Boolean represents true and false value. Next data type is void, used on function return types. Null is used when an object does not have any value. Undefined denotes value given to uninitialized variable. Next, symbol, it represents a unique constant value. And last data type is never, that represents value that never occur. So now let's understand all these data types with an example. So I'll go inside Visual Studio Code and here we will write the examples. This is the example of any data type. So I'll write here comment any type. Okay. And now we will see the number data type. Okay. So the number data type can store the integer, floating point, binary, decimal, hexadecimal number, etc. So now we'll see the example of each numbers. First we'll see with integer. Let first of type number equals to integer value like anything. Okay. So next we will see second, and this time I am assigning the float number like 123 dot 123. So we can assign integer value, we can assign the float value. Third, we can assign the binary value with the same data type, that is number. So here I'll add binary number 0B100. The binary number uses a leading 0 followed by a lowercase or uppercase letter B, and the digit after B must be 0 or 1. It means we can also assign like this capital B, and here instead of 1 we can assign 0 1 0 like that. It means the binary number will start with 0 followed by letter B and followed by digit 0 or 1. You can provide 0 or 1, after that any number. Okay. Next we will see the example of octal. And how to provide the octal number? An octal number uses a leading 0 followed by the letter O, and after this letter O we can add any number between 0 to 7. Like I'll add 1 and then I'll add 0. Okay. So it also start with 0, after that letter O, and after that we have to add number between 0 to 7 and then any number as per the requirement. So this is the example of octal number. And next we will see the example of hexadecimal. And here hexadecimal number also leading a 0 followed by a lowercase or uppercase letter x, and the digit after the 0x must be in the range of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, F. Okay. I'll comment this. It means the digit after 0x must be in the range of this. So here I'll add letter A. So it means we can assign the number data type with integer number, with float number, with binary number, with octal number, as well as with hexadecimal number. If you want, you can see the output by adding log first, and I'll copy this log and paste it after each statement. Okay, so we have written this binary twice. So I'll comment this, and now I'll run this file with command node data types. So here you can see the output. First is 123, this is number. Second is float number 123.123. Third is binary number 0B100, it means 4. And fourth is octal number 0010, it means 8. And last is hexadecimal 0xa means 10. If I change it to B and save the changes and rerun the file, you can see this is 11. With 0xb, output is 11. Okay, so this is all about the number data type. Okay, so I'll comment this code and here we will write the examples of string data type. So the string data type is used to store the text value and we can define a string using three ways. So here I'll create one variable with first way of type string equals to I'll assign value with single quote fed learning. And the second way is I'll copy the same example and here I'll edit the variable name. This is second way. So we can provide the value of the second way variable with double quotes welcome. So this is the second way of declaring string variable. Okay, here I'll close everything and I'll increase the font. And now I'll write the third variable with third way. And here we can provide the value inside back. So here I'll use dollar symbol and inside curly bracket, I'll provide the variable name. So first I'll provide second way and then I want to add one letter that is 2 and then I'll add the first way. So it means we can combine the variable of type string inside the another variable of type string with back. Okay, now save the changes and I'll log this variable. Okay, copy, paste. I'll log this first way, second way, and third way. Okay, save the changes and now open the terminal. Here we will rerun this application with node space file name. And here you can see the output. The output of first way is FAD learning. Output of second way is welcome. And output of third way using back is welcome to FAD learning. So here I'll repeat this first way string is created using a single quote and the second way string is created using the double quotes and the third way string is created using backquotes. So this is how we can create this string variable with these three ways. I'll comment this code and now let's understand the next data type that is Boolean. Okay, this is same like JavaScript. Boolean type has two values, true and false. Let me create the variable let is valid of type Boolean equals to true. So here the is valid is a variable of a Boolean type which contains the true value. And one more thing here, the Boolean with capital B is different from the lowercase Boolean type. The uppercase Boolean is an object type, whereas lowercase Boolean is an primitive type. I log this is valid variable and save the changes. Open the terminal, rerun the file, and you can see the output true. And if you not assigned any value, then you can see the output undefined because you declare the variable but didn't assign any value to that variable. Then compiler by default assign the undefined value to that variable. Okay, then I'll comment this and now we'll move to the next data type that is null. Okay, it is used when an object does not have any value. Let me create one variable with null data type. I'll create null variable with name empty of type null equals to null. So here the empty variable contains the null value. If I log this, you can see the output is null. So you can use this null data type if you want any object empty. Now let's move to the next data type that is undefined. As I already told you, when a variable is declared but is not initialized, it contains the undefined value. For example, if here I'm declaring one variable, undefined variable, and I'm not assigning any value, not providing any data type. And once I log this variable, you can see the output undefined. So we have seen this many times. Okay. Next data type is void. Void data type is used where there is no data. For example, if a function does not return any value, then we can specify void as a return type. For example, we can write function in TypeScript with name function, and I'll give the name display with type void, and inside curly bracket I'll log any message like example of void. Okay. So here we have used void data type with display function. It means that do not return any value from the function. And we don't use void with variable. Instead of that, we can use null or undefined. So we can use void with function. Next data type is symbol. So the symbol is also a primitive data type which is mostly used to create unique values. For example, if you want to create any unique value, then we can use the const keyword. I'll write the variable name unique equals to symbol and use the symbol as a property key in an object. Like we have to use the symbol with this round bracket. With the help of symbol data type, we can provide the unique value. Next data type is never. The never data type is a type that holds no value. It is like an empty set. Let me create one variable with never data type. I'll write the variable name no value of type never. So this is how we can create the variable with never data type. And here, if you assign any value to the never data type, then it will throw an error. So here you can see type string is not assigned to a type never. You can't assign any value to the never data type like string, number, boolean. No. Since a never data type does not hold any value, you cannot assign a value to the variable with never type. So here, the never data type variable does not hold any value. Then what is the purpose of this never type in TypeScript? And the answer is the never type can help us to avoid errors by making it clear that certain values or expressions are unreachable. Okay, so this is all about the built-in data types in TypeScript. And now I want to show you one more type, that is union. This is not a built-in type, but in TypeScript we can combine one or two different types of data like number, string, boolean, etc. in a single type, which is called as union type. So here I'll write example. Let union value of type, here I'll not use union word, but here I want to use type number as well as string as well as boolean to this variable. It means I can store the number, string and boolean value to this union value variable. So here you can see union value equals to, now I want to store the number value, and here I log this union value. After that I want to store the string value, union type, and then again I log this string value, and last I want to store the boolean value, that is false, and again I'll log the same union value. Okay, so now I'll save the changes and rerun this file, and you can see the output. The union variable can store the integer value like 666, and then we stored the string value, that is union type, and then we stored the boolean value, that is false. But here you can see if I delete this boolean data type from this variable declaration, you can see we are getting error. We cannot store the boolean value to this union value variable. And you can see the error. Type boolean is not signable to type string or number. So it means a union value describes a value that can be one of several types, and we can use the vertical bar to separate each type. In this example, the number, string, and boolean is the type of value that can be a number or a string or a boolean. We can't store the value inside union value variable apart from this data type. Now let's proceed with user defined data types. So these 5 data types comes under user defined data types. First is array. An array is a collection of elements of the same data type, or we can say an array is an ordered list of values. Next, we will see tuple. A tuple is an array with a fixed number of elements whose types are known. After that, we will see the enum data type. An enum is a special class that represents a group of constants. Next data type is class. Classes are used to create reusable components and acts as a template for creating objects. And last, interface. Interfaces define contract in your code and provide explicit names for type checking. Okay, so now let's understand the type array, tuple, and enum with an example, and we will dive into classes and interfaces later in their own dedicated topics. So I'll jump into Visual Studio Code. Here I'll create one more file with name user defined data types .ts, and I'll compile this whole project in watch mode with command tsc ---- watch. Okay, I'll open another terminal, and here I'll run this file with command node user defined data types. Okay, now you can see after compilation the .js file is created. I'll close this explorer, and here we will write the example of array. As I said, an array is a ordered list of values. So array stores the element which can access or update using the array index that starts from 0. And an array can be written in 2 ways. The first way is, so here I'll declare one variable with name first array of type number. So here we need to use the type of elements followed by square bracket to denote an array of that element type, semicolon. So here if you want, you can initialize the value of array like this 1, 2, 3, 4, 5, or else you can do this in separate line like first array equals to 1, 2, 3, 4, 5. Okay, so this is the first way to write array in TypeScript. So now we will see the second way. Here I'll declare the second array of type again number, but in this second way we will use generic array type. So here I'll wrap this number in angular bracket, and here I'll write array, and I'll initialize the array value like this. So this is the second way of writing array. This is called as generic array type. Okay, so I'll log this first array, and then I'll log the second array as well. I'll rerun the project, and you can see the output 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, now you can see the 1, 2, 3, 4, 5 is the first array, and 1, 2, 3, 4 is the second array. So this is the array example with number type. Now I'll write the another array example with string type. Let skills of type string square bracket, and here I'll assign empty string. Okay, so this example of string type, and if I console this skills, you will get the empty array like this. Okay, I'll comment these two consoles and we'll work on the string type array. So here I'll add one or more strings to the array. So skills with 0 index equals to, I'll add the skill Angular, and I'll add the second skill React. Okay, now I'll write the console after this, save the changes and rerun the project. Okay, here we need to change the index. React is for 1. Okay, you can see first it is empty array. After that we have added 2 skills Angular and React, or we can use the push method to add the values inside array like skills dot push And inside push, we can add the values like TypeScript. Then I'll console again and rerun the project. You can see first empty array, then Angular and React, and then we have pushed one more skill, that is TypeScript, Angular, React, TypeScript. But here, what happened if I push the integer value? So instead of TypeScript, I try to push the integer value 1, 2, 3, 4. You can see we are getting error. Argument of type number is not assigned to parameter of type string. So it means we can push only the string values into this skills array. We can't push integer, boolean, other data types value. Okay. And also we can make use of read only keyword to prevent an array from being changed. So for that, we just need to use read only. That's it. So it means we cannot change the value of this skills array. And you can see the error while adding the values inside skills array. Okay, so you can make use of this read only keyword as per the requirement. So far we have stored the same data type values in array, but if you want to store the mixed type values, in that case, we can declare array like union. So here I'll add comment mixed type values. And here I'll declare one more variable with name course of type array, and this time I want to store or I want to add the values of type string as well as number. So I can make use of this pipe symbol and I can add the data types as per requirement. Okay, so inside this course variable, now I can add a value of type string math with number 40. I can add the English with number 50 like this. Okay. And if I log this core, let me comment above consoles. And now you can see the output math 40, English 50. It means an array can store values of mixed type. For that, we have to use the syntax like type 1, type 2, and then square bracket to declare an array of values with mixed types. Okay, so we have seen the array example with same data type or different data types. Now we will see the example of tuple data type. A tuple works like an array with some additional considerations, like the number of elements in the tuple is fixed and the types of elements are known and need not be the same. For example, we can use a tuple to represent a value as a pair of string and a number. So here I'll declare one variable with name house of type string, comma, number. So we can declare a tuple data type with this square bracket, and inside square bracket we have to write the data types. And now I'll add the value inside this house variable equals to inside array. Let's say the house name is white and the number is 100. Okay, so here the order of values in a tuple is important. If you change the order of values, for example, here instead of string and number, if I assign first number and then string, you will get an error. The number is not assigned to type string. Also, we can't add the more values like this, we will get an error. So you can see the error string number is not assigned to type string and number. So it means the number of elements in a tuple is fixed. So I log this house and we will see the output white and 100. And one more thing, we can make tuple type is read only so that we can't push values inside tuple. Okay, so this is all about tuple. Now we will see the example of enum. Enum stands for enumerated type, and an enum is a special class that represents a group of constants. And enum comes in two flavors like numeric and string. So first we will see the example of numeric type and then we will move on to the string. So here I am going to create enum that represents status code. So to define an enum, first use the enum keyword followed by the name of the enum, that is status code. define constant values for the enum. So here inside curly bracket, I'll add constant values. So here I'll add not found, then I'll add success, accepted, and last I'll add bad request separated by comma. And after that, I'll log the status code. Okay, so in this example, the enum name is status code and the not found, success, accepted, bad request are the constant values. Now I'll run this file and here you can see the output. By default, enums will initialize the first value to 0 and add 1 to each additional value like 0, 1, 2, 3, 0, 1, 2, 3. And if I initialize 1 to this not found, then you can see the output 1, 2, 3, 4. Okay, save the changes and rerun this project. And now you can see the output 1, 2, 3, 4. It means we can set the value of a first numeric enum and it will auto increment from that. Like I have initialized 1 and the value you can see 1, 2, 3, 4. If I assigned 5, you can see the output 5, 6, 7, 8. And also we can assign the unique number values for each enum value. Then in that case, the values will not increment automatically. We will see the example. I'll initialize 404 to this not found and 200 to this success. I'll add 202 for this accepted and for bad request I'll add 400. Okay, now save the changes and rerun this file. You can see 200 for success, 202 for accepted, 400 for bad request and 404 for not found. So it means if you assign unique numbers to each enum, then the value will not increment automatically. Okay. So this is the example of numeric enum. Now let's see the example of string enum. So here I'll write enum keyword first and followed by name of the enum. I'll write direction, curly bracket, and inside curly bracket, I'll add the constant values north, east, south, and west. Okay. And I'll log this direction. Now here, if I want to log the north value of this enum, then I'll write here direction.north and I'll run this project and you can see the output 0. Okay, I'll comment this status code console, save the changes and rerun. You can see the output is 0 because by default enum will initialize the first value to 0. And if I want to print south, you will see the output 2, 3 because 0, 1, 2. And if I want to print the north, east, south, west, then I have to initialize the string value to each enum value. Like for north, I'll assign north. For east, I'll assign east. For south, I'll assign the value south. And for west, I'll assign west. Okay. In this case, I'll shift F for my document. I'll rerun this project. Now you can see the output south. For east, you will get output east. See. Okay. And if I print whole direction, you will see the complete object north, east, south, west. Okay. So this is all about user defined data types. We have seen the example of array, then tuple, then enum. Now we will proceed to investigate other essential TypeScript data types such as object type, type aliases, and string literal types. So what is object type? An object is a collection of key value pairs where each key is unique and maps to a specific value. And what is type aliases? Use type aliases to define new names for existing types. And last, string literal. It defines a type that accepts specified string literal. Now let's see the example of these three types. So here I'll add comment object type. Okay, so object is defined with this curly bracket. So now I'll declare the variable with name obj of type object, open and close curly bracket, and inside that I'll add key as a name of type string, and the second key I want to add age of type number. Okay, and I'll initialize the value. So while initialization, we need to add key value pairs. So key is name. So I'll add the value of this name key, John, and the another key is age. And the value of this age key is 30. Okay, so 30 is a number, so no need of quotes. And now I'll log this object, obj. So here you can see we have declared one variable with name obj, and this is of type object. That is why we have used curly bracket, and inside curly bracket we need to add the keys with data type, and we need to add the values inside this object in the form of key value pair. Okay, so I'll run this project and you can see the output object with name John and age 30. And here inside object, we can declare properties optional. Optional properties are properties that don't have to be defined in the object definition. So this is the object definition. If you have declared any of this property optional, then you can skip that property while defining the object. And optional properties are denoted with question mark like this. So in this case, if I remove this age, then also I'll get the output with name John. But if I remove this question mark, you can see we will get error. Property age is missing in type name string but required in type name string age number. Okay. And one more thing, by using interface, we can specify the properties of an object. Like instead of declaring this property here, we can declare that inside interface. Like here, I'll create interface with name, person, and inside interface, I'll pass this name and age. And instead of this curly bracket, here we just need to pass the interface name, that is person. In this case also, we will get the same output like name, John, and age 30. Okay, so to declare the properties of object, we can make use of interface.
Now next we will see the example of type alias. So the type alias allows you to create a new name for an existing type. So to define a type alias, we use the keyword type followed by the alias name. I'll take char name equals to the type it represents. I'll write string. So in this statement, char name is a type alias name for string data type. And now I'll declare variable with name, student name, and I want the student name with string data type. So here, instead of string, I can write char name because we have assigned string data type to the char name. Okay. So similarly, I can create one more variable with student address, and again, instead of string, I'll assign char name. So here we are using the same data type in many places. It means the type alias creating reusable types that can be used in many places in the code base. Okay. So in this example, we have created char name as a type alias for the string data type and use it to declare two variables, student name and student address. So now I can assign any string value to student address as well as student name. So here for student address, I'll assign Mumbai, and for student name, I'll assign Vishal. But here, instead of character, if I assign number 1, 2, 3, you can see we are getting error. Type number is not assignable to type string, because the student address and student name of type string, not a number. We can make use of union type if you want to assign different data types value. So what we need to do here, we need to add the pipe symbol and then we can add the data type as per requirement. So you can see once I add number data type, there is no error. So here I'll create one more variable with student age and I'll assign the same alias name, that is char name, and here I'll assign the value to the student age equals to 20 and I'll assign name Vishal because this is name, so it should be in string. So this is the example of type alias. We have seen type alias with string type as well as union type. And type aliases can be useful for simplifying complex type, making code more readable. And as I said, type aliases can be useful for creating reusable types that can be used in many places in the code base. So next type we will see string literal. Okay, a TypeScript string literal type defines a type that accepts specific string literal. So here I'll declare one variable with name keyword and I'll assign one string to this keyword, that is enter. Okay, so here keyword variable can accept only one string, that is enter. So in this case I can assign only enter value to the keyword. So this is valid. But if I try to assign the different value to the same keyword variable, like if I assign backspace, you can see we are getting error. Backspace is not assignable to type enter. It means here, while declaring the keyword variable, we have provided the specified string literal as a type of that variable. It means this keyword variable can accept only this string. And if I try to assign the different string, it will throw an error. But again here, we can use the string literal types with union type and type aliases to define types that accept a finite set of string literals. Like here, we can add pipe symbol and we can add backspace. You can see no error with keyword. So here we can assign as many string as we want. Like I'll assign shift. So in this case, if I assign the shift value to this keyword, then I'll not get error. But if I try to assign the different string like delete, now we are getting error because we didn't specify the delete string to this keyword variable. That is why we are getting error here. Type is not assignable to type. Enter backspace shift. It means we can assign only enter backspace shift to the keyword variable. Okay, so this is the example of string literal. Now I'll go back to PPT and let's learn about type assertion. So the type assertion is a mechanism which tells the compiler about the type of a variable. It means type assertion is a way to tell the compiler that you know more about the type of a value than it does. And when TypeScript determines that the assignment is invalid, then we have an option to override the type using a type assertion. So TypeScript provides two ways to do type assertion. First is using angular bracket and second is using as keyword. And here you can see how to do type assertion with angular bracket. Like inside angular bracket, we have to specify the type of variable, that is number. And using as keyword means we have to write as keyword between name of variable and the type of variable, like code as number. We'll see the same example in Visual Studio Code. Here I'll write the comment type assertion. And after that, I'll write the same example here. I'll change the name. This is EMP code and this is employee code. So in this example, we have a code variable with type any. And in the line number 84, we have assigned the value of this code variable to the another variable called EMP code. However, we know that the code is of type number even though it has declared as any. So in this case, while assigning code to this EMP code, we have asserted that code is of type number using angular bracket, as well as in the line number 85, we have asserted the same code is of type number using as keyword. And now the type of this employee code and EMP code is number. Okay, now I'll run this file and you can see the output number. So similarly, you can see the type of EMP code, number and number. So it means type assertion allows us to set the type of value and tell the compiler not to infer it. So in such scenario, we can use type assertion, and I'll show you another example of type assertion for IntelliSense. Okay, I'll comment these two lines, and here we will write the another example. For that, I'll declare one more variable with name, channel name of type string equals to, I'll assign value FD. Okay, now I want to use the property of length. So for that, I'll write channel name. So here after pressing dot, I can choose length. So I'll add this inside log. Okay, save the changes and I'll run this project, and you can see I'll get output 11. The length of this FAD learning is 11. But instead of assigning value here, if I declare variable and if I assign the value of this variable in the next line, like channel name equals to FAD learning, in this case, I want to calculate the length. So for that, I'll write channel name and after that, I'll press dot. You can see we can't get IntelliSense after pressing dot. So in this case, I can make use of type assertion and I can see the type IntelliSense after pressing dot. So for that, what I need to do? I need to wrap this channel variable inside round bracket, and here using angular bracket, we have to specify the type of this variable, that is string. And now I'll delete this dot. Once I press dot, I'll get the IntelliSense. You can see. Now I can use length property. So I'll add this statement inside console. Okay, now you can see the same output, that is 11. So this type assertion we did with angle bracket. Similarly, you can use as keyword like variable name as keyword and then type of variable, that is string. So in this case also you will get the same output, that is 11. So this is how we can tell to the compiler about the type of variable. So we have seen two different examples of type assertion. One is for normal variable of type any and the other example for type IntelliSense. So that's it for type assertion. We have now completed basic data type concepts of TypeScript. So there are two main purposes of data types in TypeScript. First purpose is types are used by the TypeScript compiler to analyze your code for errors. And the second purpose is types allows you to understand what values are associated with variables.
So let's understand the types of control flow statements. Control flow statements determine the order in which your code is executed. Also, they allow us to make decisions, repeat actions, and handle different situations. Control flow statement can be categorized into three primary types, that is conditional statement, looping statement, and branching statement. Branching statement is also called as jump statement. So under conditional statement, there are four statements: if, else if, and switch statement. And under looping statement, there are three loops: for loop, while loop, and do while loop. Break and continue comes under branching statement. So let's look at one-liner definition for each control flow statements. First statement is if, else, and else if. This is a fundamental control flow structure that allows us to execute different block of code based on a condition. If statement executes a block of code if a specified condition is true. Else statement executes a block of code if the preceding if condition is false. And else if statement allows for multiple conditions to be checked sequentially. And the second statement is switch statement. It evaluates an expression and executes the corresponding block of code based on the matching case. So these two statements fall under the type of conditional statements. And next, break and continue come under jump statement, where break statement is used to determine the current loop switch statement or labeled statement. Or we can say break statement exits a loop prematurely, whereas continue statement is used within loops to skip the rest of current iteration and move on to the next one. So moving on, we have three looping statements: for, while, and do while, where for loops are used to iterate over a block of code a certain number of times. There are three main types of for loops in TypeScript. First is traditional for loop, second is for in loop, and third is for off loop. We will explore these types through practical examples during the hands-on. The next loop is while loop. It repeats a block of code as long as a specified condition is true. And the last loop is do while loop. This do while loop is similar to a while loop, but the code is executed at least once before the condition is checked. So that's all about the basics. Now let's open Visual Studio Code and apply these control flow statements through hands-on exercises.
So here inside Visual Studio Code, I'll create one more file with name control flow statements.ts. And inside this file, I'll log one message test. Okay. And now I'll open terminal with control plus backtick. And here first I'll compile this whole project in watch mode with command tsc ---- watch. Enter. And after compilation, you can see control flow statements.js file is created. So now I'll open one more terminal and here I'll run this control flow statement file with command node space file name control flow statement. Enter. And here you can see output test. So now we will start writing examples of each statement here. Okay. So first I'll write down the comments to save time. So here first we will see the control flow statements and then we will see jump statements and last we will see looping statements. Okay. So under this conditional statement, first we will see the example of if, else and else if statement. So for that, I'll pause the video and I'll write the sample code to save time. So in this example, you can see I have declared one variable with name marks. Here I have written one if condition and then I have written two else if condition and at last I have written one else block. So in this case, if the if condition evaluates to true, then only this if block is executed. And if the if condition evaluates to false, then it will check the next else if condition. And if the next else if condition is also evaluates to false, then it will go to the second else if condition. And if this condition also evaluates to false, then finally it will print the else block, that is grade F. Okay, so this is the hierarchy of if, else and else if block. So here I have declared one variable with name marks and I have initialized value 75. If the marks is greater than or equal to 90, then grade A will get print on console. And if the marks is greater than or equal to 80, grade B will get print on console. Similarly, if the marks is greater than or equal to 70, you can see the grade C on console. And if the mark is less than 70, then you can see the message grade F on console. So in this case, our marks is 75. Then it will go inside this second else if condition because the marks is greater than or equal to 70. Then we should get the message on console grade C. Now I'll run this file and you can see the output grade C. Okay. If I change the marks like 95, now this time first if condition evaluates to true, then it will print grade A. And if I change it to 50, in this case, it will go inside else block. I'll run this file and you can see the output is grade F. So use if statement to execute code based on a condition. Use else statement if you want to execute code when a condition is false. And use else if statement to execute code based on multiple conditions. Okay. So I'll comment out all these code and let's move on to the second statement, that is switch statement. The switch statement allows us to evaluate an expression and execute different code blocks based on the value of the expression. So here I'll quickly write down the example of switch statement and then I'll explain. So in this example, I have declared two variable, one with name day and I have assigned value 2, and second with name day name of type string. And here inside switch, I am passing the variable day. It means I am passing the value of day variable, that is 2. And inside this switch case, I have written multiple cases like case 1, case 2, case 3. And inside this case, I have initialized a value to the day name variable. Okay. And after that, I have written one break statement. Okay. And after these three cases, I have written the default case. Okay. And last, I logged one console with today's date plus I have concatenated the dname variable inside console. So here this switch expression is evaluated once at the beginning, and after that this each case clause checks if the expression's value matches the specified value. Like if a match is found, then the corresponding code block is executed. And this break statement is crucial to exit the switch block after a match. Without it, execution falls through to the next case. Okay. And this last default clause executes if no case matches the expression, then this corresponding code block is executed. So here our day value equals to 2. It means it will go inside case 2 and it will execute the corresponding code block, that is day name equals to Tuesday. And after that this break statement exit a switch statement prematurely. Okay. So I'll run this file and we will see the output. And here you can see the output. Today is Tuesday. If I change it to 1, then in that case, you can see the output today is Monday because it has executed first case. And if I assign 4 to day variable, in that case, you can see we don't have the case for 4 value, then it will go inside default and you can see the output today is unknown. Okay, I need to save the changes. And now I'll rerun this file and you can see the output today is unknown. And now let's understand the branching statement, that is jump statements. So inside jump, there are two statements such as break and continue. Break statement is used to exit a loop or a switch statement prematurely. So just now we have seen the break statement example with switch case. But now we will see the break statement example with for loop. I'll increase the font size again. And for that here, I'll write down the for loop. I'll initialize one variable, let I equals to 0 and then I is less than 10 and I plus plus. Okay, inside for loop, I'll print variable I. Okay, save the changes. Now I'll run this file and you can see the output 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But here what I want to do, I want to break this iteration when the value of I equals to 5. So in that case, I'll add one if condition here, value of I equals to 5, and inside if block, I'll add break statement. So it means if the value of I equals to 5, then break statement exit loop. So in this case, break statement help us to exit the loop when the value of I is 5. Okay. So I'll save the changes and I'll rerun this file. You can see this time the output is 0, 1, 2, 3, 4. So this is how we can use the break statement in our for loop. So next we will see the continue. So for continue, I'll use same example. In this example, if you want to skip any specific iteration, then you can use continue statement. Like here, if I want to skip the third iteration, then I can write here one more if condition I equals to 3. Then inside this if block, I can write continue statement like break statement. And this continue statement will help us to skip the iteration when the value of I is 3. Because the continue statement is used within loops to skip the rest of the current iteration and move on to the next one. Okay, I'll save these changes and rerun this file. And now this time you can see we are getting output 0, 1, 2 and 4. And without continuous statement we are getting 0, 1, 2, 3, 4. So it means that once the value of variable I equals 3, the continue statement skips the current iteration and moves on to the next, and the variable I increments by 1 becoming 4. Since 4 is less than 10, 4 will be printed to the console. So that is why we are getting output 0, 1, 2, 4. So this is how we can make use of break and continue statement in the TypeScript code. Okay, I'll comment out this example of continuous statement. And now let's move on to the last type of statement, that is looping statement. And inside looping, now let's start with for loop. This for loop repeats a block of code a specific number of times. And this for keyword is used to create loops. And as I said, there are 3 variations of the for loop, like normal for loop, and then for in loop, and then for off loop. Okay, we will see one by one. So first is traditional for loop. This loop is used when you know in advance how many times you need to iterate. And this for loop statement creates a loop. It consists of 3 optional expressions separated by semicolon and enclosed in parentheses, like for open and close parenthesis, and inside that I'll declare one variable, let I equals to 0. This is called as initialization. And next is we need to write the condition, that is I is less than 5. And the third one is expression. So here I'll increment the value of I. And after that I'll write open and close curly bracket. So here first is initialization, is an expression evaluated once before the loop begins. We use the initialization to initialize a loop counter. And second is condition, is an expression that is evaluated at the end of each loop iteration. If the condition is true, the statement in the loop body executed. And the third is expression. So this expression is evaluated before the condition is evaluated at the end of each loop iteration. Generally, we use the expression to update the loop counter. And all 3 expressions in the for loop statement are optional. Okay, inside for loop, I log the value of I. Save the changes and run this file. You can see the output 0, 1, 2, 3, 4. So how it works? First, we have to declare one variable like I and initialize it to 0. Then after that, check if I is less than 5. If it is, output I to the console. And after that, increment the variable I by 1. And finally, repeat this step until I equals to 5. Okay, so this is the example of for loop. Now we will see the example of for in loop. This for in loop iterate over the properties of an object. So for that, here I'll create one object with const keyword. The name of object is resume equals to, I'll assign the values of object in the form of key value pair. So here I'll take name equals to John, experience equals to 5 years, and last technology. I'll write UI development. Okay, so this is our object, and after that I'll write one for loop, and inside this for loop I want to iterate the properties of resume object. Inside for loop I'll write the resume. So for that, here I'll create local variable with name let item in resume. So here we are using in keyword, that is why this is called as for in loop. Okay, and inside this I'll log the atom. Okay, now save the changes and run this file again. Here you can see the output: name, experience and technology. So here we are not getting the value of object, but with the help of foreign loop we can access the properties of this resume object. Property means keys of this object. These are the keys and these are the values. So if you want to access the properties of object, then we can make use of for in loop in TypeScript. So now next we will see the example of for of loop. And this for of loop iterates over the value of an array. So for that I'll create here one array with name numbers and equals to I'll assign value 1, 2, 3, 4, 5. And now I'll write the syntax of for of loop. So for that we need to write for keyword and inside parenthesis. Again here we need to declare one variable. Let element, this is a for of loop, so I'll use of keyword. Let element of, so here we are iterating the values over numbers. So after of I'll write numbers and then open and close curly bracket and inside that I'll log the element. So in this case you can access the value of this number array. Okay, I'll run this file and you can see the output 1, 2, 3, 4, 5. Okay, so if you want to access the value of array, then you can make use of for of loop, and if you want to access the properties of object, then you can make use of for in loop. Hope you understand the concept of for loop. Okay, I'll comment out all these for loop examples, and now we will move on to the next loop, that is while loop. While loop statement allows us to execute a block of code repeatedly as long as a specified condition remains true. So here I'll declare one variable with name I equals to, I'll initialize value 0. And after that here I'll write while, and inside while we need to add condition. So my condition is I less than 5. And inside curly bracket I'll log the value of I. And after that I'll increment the I variable. Okay, so this is the syntax of while loop. So how it works? If the condition is true, then only the block within curly braces is executed. And after the code block is executed, the condition is evaluated again. And this process continues until the condition becomes false. Okay, so here while loop is also called as pre-test loop because the while statement evaluates the condition before its body executed. Okay, so I'll save the changes and run this file. You can see the output 0, 1, 2, 3, 4. And last we will see the example of do while loop. So for that I'll take same example of while loop and I'll comment out this while loop example. Okay, and here I'll do minor changes. So I'll cut this while condition from here and I'll paste this after this block. And instead of while, I'll write here do. Okay, this is the syntax of do while loop, or we can say this is the example of do while loop. And after this condition, semicolon is needed. Okay, so this do while loop executes a block of code at least once and then repeats the loop as long as a specified condition evaluates to true. So here what we did, we declare one variable I and initialize it to 0 before entering the loop. And after that we logged the variable I and increment it by 1. And then we are checking if it is less than 5, then repeat the loop until I greater than or equal to 5. It means do while statement first executes statements in its body surrounded by the curly braces and then check the condition. It means the do while statement always executes its body at least one, and that is the reason it is called as post-test loop. Okay, I'll repeat. The while loop is known as pre-test loop because it evaluates the condition before executing the loop body. Whereas the do while loop is called as post-test loop since it checks the condition after executing the body at least one. Okay. So at last I'll run this file and you can see the same output 0, 1, 2, 3, 4. Okay. So that's it for control flow statements. Now let's dive into TypeScript operators. TypeScript operators can be grouped into the 8 key categories. First is arithmetic operators. Operators who take numeric values as operand and perform some action on the operands to return a single numeric value. And in TypeScript, there are 7 arithmetic operators such as addition, subtraction, division, multiplication, modulus, increment, and decrement. Next operator is assignment operator. Operators which are used to assign values to the operands. So there are 6 assignment operator like assign, plus and assign, subtract and assign, multiply and assign, divide and assign, and modulus and assign. Next operator is comparison operator, which is also called as relational operator. Operators which are used to compare or to define a relationship between two operands and return a boolean value true or false. And in TypeScript, there are 8 relational operators or comparison operators such as greater than, less than, greater than or equal to, less than or equal to, identical, not equal to, and not identical. And the next operator is logical operators. Operators which are used to combine two or more conditions into a single expression that returns a boolean value true or false. And there are 3 logical operators such as logical and, logical or, and logical not. Next operator is bitwise operator. Operators which are used to perform bit manipulation and bitwise operations on operand. And in TypeScript, there are 7 bitwise operators such as bitwise and, bitwise or, bitwise x or, bitwise not, bitwise right shift, bitwise left shift. And the last is bitwise right shift with 0. Next operator is ternary operator, which is also called as conditional operator. This operator requires 3 operands and returns a boolean value based on the condition. So inside bracket, we need to pass 3 operand like operand 1, then question mark, operand 2, then colon, and operand 3. And this is a shorthand way of writing an if-else statement. Next operator is concatenation operator. The concatenation operator is used to join 2 or more strings into one single string, and it indicates with plus symbol. Next and last operator is type operator. Operators which are used with object such as type of, instance of, in or delete operator. So that's all about the basics of TypeScript operators. Now I'll open Visual Studio Code and let's understand these operators with practical examples. So here inside Visual Studio Code, I have created new file with name operators.ts and I compiled this project in watch mode. So you can see the operators.js file is created. And now here I'll log the message TypeScript operators and save the changes, and I'll open one more terminal, and here I'll run this project with command node operators. Enter. And here you can see output TypeScript operators. Okay, so here we will start writing the examples of each operator one by one. So here I'll quickly add the comments for all operators. So here first we will see an example of arithmetic operator. For that I'll declare one variable with keyword let, and the variable name is num1 of type number equals to 4. And here I'll add comma and I'll create one more variable with name num2 of type number and equals to 2. And after that I'll declare one more variable with name result of type number equals to, I'll add these two numbers num1 plus num2, and after that I'll log the result. Now I'll open terminal and here I'll rerun this file with node operators, and you can see the output 6. 4 plus 2 is 6. So similarly, I can do the subtraction using subtraction operator. Save the changes and I'll again rerun this file. You can see the output 6, 4 minus 2, 2. So similarly, I can do division. You can see output 2, multiplication. Now you can see output 8. Now with modulus, you can see output 0. And for increment and decrement, here I'll write num1 plus plus and here num2 minus minus. And now I'll log num1 as well as num2. Save the changes and I'll rerun this file again, and you can see the output. Number 1 is printing 5 and number 2 is printing 1. Because we are incrementing the number by 1, that is 4 plus 1, 5, and we are decrementing the number 2, that is 2 minus 1, 1. Okay, so this is all about arithmetic operators. So here I'll comment out the all code of arithmetic operator. And now let's understand the next operator, that is assignment operator. So here I'll declare one variable with name a of type number equal to any number like 10. So here I am using equal to sign. This is nothing but the assign operator. So we are using assign operator to assign the value of that particular variable. So here we are assigning 10 value to variable a. So this is our assign operator. Next, we will see add and assign operator. So for that, I'll create one more variable, let b of type number equals to, I'll assign value to variable b is 20. Okay. After that, here I'll use the add and assign operator to add the value of variable a and variable b. So for that, here I can write b plus equals to a, and then I'll log the value of b. Save the changes and now I'll run this file. You can see the output 30. So here this b plus equals to a, it means b equals to b plus a. Okay. So here this add and assign operator between these two variables, it represents b equals to b plus a. Similarly, we can use the subtract and assign operator. I'll save these changes and you can see the output 10. For multiplication, you can see output 200. Similarly, for divide, you can see output 2. And last, for modulus and assign, you can see output 0. So this is how we can use the assignment operator in TypeScript. So again, I'll comment out this code and we'll move on to the next operator, that is comparison operator. So for comparison operator, again I'll declare two variable with type number and I'll assign some value like 3, and for variable b I'll assign value 2. And now we want to use the comparison operator between these two numbers. So for that, here I'll add one if condition, and inside if I'll add condition a equals to b, then I'll log one message condition true. Okay. Save the changes and now I'll run this file. See, there is no message on console. So here I'll add the else, and inside else I'll log the message condition false. So now you can see the message condition false because value of a variable is not equal to value of b variable. And if I change the value of b variable is to 3, and now I'll run this file and you can see the output condition true. So this time our if condition returns true That is why we can see the condition true message on console. So here now what I'll do, I'll wrap this 3 inside string. Okay, and here instead of number, I'll change the data type to any. I'll rerun this file and you can see the output condition true. And if I change it to triple equal to, and now I'll save this file and rerun this file again. This time you can see the output condition false. It means the double equal to only checks the value and it will not check the data type of that variable. Whereas triple equal to check the value as well as data type. If the values and data types are same, then only it will return true or else it will return false. But with double equal to, it will check only value. It don't care about the data type. That is why with double equal to, we are getting output condition true because we have assigned the same value to variable A and variable B. Okay, so that is the difference between double equal to and triple equal to, or we can say the equal to and strict equal to. So this triple equal to symbol is called as identical or strict equal to, and this symbol is called as not equal to, and this symbol is called as not identical or strict not equal to. Okay, so now we will see with not identical operator. So I'll save these changes and I'll run this file. You can see the output condition true because these two are not equal. That is why this condition returns true. But now if I delete one equal to and now I'll run this file and you can see the output condition false because this condition means A is not equal to B. And with equal to symbol, it checks only value. It will not check the data type. So that is why this condition is written false and we are getting output condition false. So far we have seen equal to, identical, not equal to, not identical operator. Now I'll change the type of B variable to number and here I'll remove this string and I'll change the value to 6. Okay, and here instead of not equal to operator, I'll write greater than operator. And now I'll run this file. You can see output condition false because value of A variable is not greater than value of B variable. So now I'll change the operator to less than, and in this case it will print condition true because the value of A variable is 3 and this is less than value of B variable, that is 6. Similarly, we can use less than or equal to, and in this case again it will print condition true, and if I change it to greater than or equal to, and this time it will return condition false. And instead of 6, if I assign value 3 to variable B, then you'll get output condition true because this time A is not greater than B, but A is equal to B. So that is why it returns true and we will get output condition true. So this is how we can write the comparison or relational operator in our TypeScript code. So I'll comment out this code and now we will move on to the next operator, that is logical operator. So here logical operators which are used to combine two or more conditions into a single expression that returns Boolean value true or false. So it means here I'll simply log the true and false value with logical and or and not operator. So here I'll write false and true and I'll use the logical operator and between these two Boolean values, true and false. And now let's see what it will print. I'll run this file and you can see the output false because this logical AND operator returns true only if both operands are true. So in this case, one operand is false and the another operand is true. That is why it is returning false. But if I change it to true, Now this time you can see the output true. Okay. Similarly, we will see the second operand, that is logical OR. And this logical OR operator returns true if at least one of the operands is true. So in this case, you'll get output true. If I change it to false, then also we will get output true. And if I change both to false, then only we will get false. Okay, now we will see the not operator. Not operator inverses the boolean value of its operand. That's it. So for that, we will take only one operand, and here I'll add not operator, and now we will get output true, because the use of this not operand is inverse the boolean value of its operand. And if I change it to true, now we will get output false, like this. Okay, so I'll comment out this console as well, and I'll minimize this code. You can see so far we have covered 4 operators: arithmetic operators, assignment operators, comparison operators, and logical operators.
Under this bitwise operator, first we will understand the AND operator. So with the help of PPT, we'll try to understand the bitwise operators. The bitwise name indicates that bitwise operators are used to perform operations on individual bits of binary numbers. So this is the table of binary representations for the decimal numbers 0 to 10. So first, let's understand how bitwise AND operator works. The bitwise AND operator indicates with a single ampersand, and it takes two numbers, perform bitwise AND operation. And the result of bitwise AND operator is 1 when both bits are 1. So here you can see there are two decimal numbers, one is 5 and another is 3, and the binary representation of this 5 is 0101. The binary representation of 3 is 0011. So here the AND operator compares each bit of 5 binary number with corresponding bits of 3 binary numbers. And if both bits are 1, the resulting bit is 1. Otherwise, the resulting bit is 0. So here you can see 1 and 1 equals to 1, 0 and 1 equals to 0, 1 and 0 equals to 0, 0 and 0 equals to 0, because the result of AND operation is 1 when both bits are 1. So in this fourth position, you can see 1. So the result of binary representation of 5 and 3 equals to 1. 0001, it represents the decimal number 1. Okay, so let's write the code for this. So here I'll declare one number with name num1 equals to, I'll assign same value 5, and it represents binary value 0101. And next number I'll declare with name num2, and here I'll assign 3, which represents the binary number 0011. Okay, and now I'll log number 1 and number 2. And here between these two numbers, I want to perform the bitwise AND operation. That is why I'll add ampersand symbol. Now save the changes and I'll run this file, and you can see the output 1 decimal number, because we are passing decimal number 5 and decimal number 3, and we are getting output in decimal number 1. Next, understand the bitwise OR operator. And the bitwise OR operator indicates a single vertical line, and it also takes two numbers and perform OR operation. And here the result of bitwise OR operator is 0 when both bits are 0. So let's understand the same example with OR operator. So here you can see the decimal number 5 and 3, and here I have written corresponding binary bit of decimal number 5 and 3. So here the operators compares each bit of these two operands, like operand 1 is 5 and operand 2 is 3. So the operator compares each bit of two operands, and if both bits are 0, then only the resulting bit is 0. So in the fourth position, you can see both bits are 1. The resulting bit is 1. Here the first bit is 0, but second bit is 1. Resulting bit is 1. In the second position, first bit is 1 and second bit is 0. So the result is 1. But in the first position, both bits are 0. So the resulting bit is also 0. So it means the result of OR is 0 when both bits are 0, or else the result is 1. So the final result of OR operation between these two operand 0101 and 0011 is equals to 0111, means the decimal number is 7. So let's write the same example on Visual Studio Code. So here, instead of AND, I'll add pipe symbol, and now you can see the output 7. Okay, so let's understand the next operator, that is bitwise NOT operator. And the bitwise NOT operator represents by the tilde character like this. So the bitwise NOT is a unary operator. So it takes one number and perform NOT operation. And its job is to complement each bit one by one. So it means the result of NOT is 0 when bit is 1, and the result of NOT is 1 when bit is 0. So here you can see the 7 in decimal, which is 0111 in binary, and the binary operator inverts each bit, like every 1 becomes a 0 and every 0 becomes a 1. So here you can see 1 is 0, 1 is 0, 1 is 0, and this last 0 is 1. And resulting in 1000, it means output is 8 in decimal. Now let's understand the next operator, that is bitwise XOR operator, and it represents by the up arrow symbol like this. The XOR operator is similar to the OR operator but with a key difference. The result of OR operator is 0 when both bits are 0, whereas the result of XOR operator is 0 when both bits are the same, either 0 or 1. So here you can see with an example. For OR operator, the result of OR operator is 0 when both bits are 0. And here for the XOR operator, the result of XOR operator is 0 when both bits are same. So either 0 or 1. So here you can see 1 and 1 resulting 0, but 0 and 1 resulting 1, 1 and 0 resulting 1, and 0 and 0 resulting 0. So the difference is for OR operator, if both are 0, then result is 0. And in the XOR operator, if both bits are same, either 0 or 1, then only result is 0. So let's write the same code in Visual Studio Code. So here I'll write the symbol of XOR operator, that is up arrow, and now I'll save the changes, and here you can see the output is 6 and it represents 0110. Okay, so next operator is bitwise left shift operator, and it represents with this symbol like two less than operators. So this left shift operator is used to shift the bits of binary numbers towards left. And how it works? So in this example, this is the left operand and this is the right operand. So left operand is a number whose bits are being shifted, and the right operand is the number of positions to shift the bits to the left. So here 2 is a decimal number and the binary representation of 2 is 0010. Here we have to shift each bit one position to the left. So during the left shift operator, the first bit or the most significant bit is discarded, and then the second bit will shift here, third bit will shift here, and fourth bit will shift here. And the last bit or least significant bit becomes vacant, and the vacant digit or bit is filled with 0. So here we have to insert 0. So it means during this left shift operator, the first digit is discarded so that the last digit becomes vacant, and that vacant digit is filled with 0. So here zeros are filled in on the right as the bits are shifted left, and the binary representation of 2 is 0010, and shifting the bit left by one position and resulting in 0100, which is 4 in decimal. Okay, so let's try this inside Visual Studio Code. Here I'll comment the second number, and here I'll assign 2 to this number 1, and here I'll add left shift operator and I want to shift one position to left. I'll save the changes and you can see the output 4. The same we have seen here. 2 becomes 4 with left shift operator. Similarly, we can understand the next operator, right shift operator. And this right shift operator indicates with this symbol like 2 greater than operators. In the right shift operator, shift the bits of binary numbers towards right. So here you can see the same example. This is the left operand and this is the right operand. And in between these two operand, we are using the right shift operator. And the left operand is a number whose bits are being shifted. And the right operand is the number of positions to shift the bits to the right. So here you can see this time we have to shift the number towards right. So in this case, the least significant bit is discarded and this 1 will shift here, 0 will shift here, this 0 will shift here and the first bit or the most significant bit becomes vacant and the vacant digit is filled with 0. So we have inserted 0 to this first position. I'll repeat. During the bitwise right shift operator, the last bit is discarded. Because of that, the first digit become vacant and the vacant digit is filled with 0. So the binary representation of 2 is 0010 and the shifting the bits right by one positions result in 0001 which is 1 in decimal. So let's quickly do this inside Visual Studio Code. So instead of this left shift, I'll write right shift. Now save the changes and run this file. You can see the output 1. Okay. So we have seen AND operator, OR operator, XOR operator, NOT operator, right shift operator, left shift operator, and the last operator under this bitwise operator is right shift with 0 operator. And it represents with triple greater than operator. And this bitwise right shift with 0 operator shifts the bit of the left operand to the right by the number of positions specified by the right operand, like 1, and filling the leftmost bit with zeros. Like here, we are filling the leftmost bit with 0. If we are shifting 2 bits to right, then we have to fill 2 zeros to the left side. So it is similar to the right shift operator. So I'll save these changes and I'll run the file. You can see the same output we are getting 1. And if I change this to 2, now you can see the output 0 because we are shifting 2 bits to right. So here this is the binary representation of 5 and the binary representation of is 0010. And if I shift these two 1 and 0 bit towards right, then we have to fill 2 zeros to the left. So the answer is 4 times 0, which is 0 in decimal. Okay, so this is how the bitwise operator works in TypeScript. And now we'll move on to the next operator, that is ternary operator. Or ternary operator is also called as conditional operator. So this operator requires 3 operands and returns a Boolean value based on the condition. And also we can say this is a shorthand way of writing an if-else statement. So while learning control flow statements, we have already seen how if-else statement works. So here ternary operator enables the simplification of if-else block, reducing multiple lines of code to a single line. So here first I'll write example using if-else block and after that we will write same example using ternary operator. Okay. For that I'll declare one variable with name A of type number equals to 5 and after that I'll declare one more variable with name B of type number and I'll not assign any value to variable B. And after that here I'll add one if condition and the condition is A is greater than 4, then B equals to A. Okay. And if this if condition returns false, for that I'll write else block and inside else block I'll write B equals to 0. Okay. And after that I'll log the variable B. Now save the changes and I'll run this file and you can see output is 5 because this if condition returns true. value of a variable is 5 and 5 is greater than 4, and it has executed the if block code, which means b equals to a. Value of a is equal to value of b, and the value of b is 5. And here, instead of 4, if I write, then you'll get the output 0, because 5 is not greater than 6. That is why this if condition returns false, and it will execute the else block, that is b equals to 0. So now I'll comment out this if else condition, and instead of that, I'll write the same code using ternary operator or a conditional operator. So for that here, so what we want here, we want to assign the value of a variable to value of b variable. B equals to, now here, as I said, this ternary operator requires 3 operands. First operand is separated with question mark and second operand is separated with colon. Okay. So now we have to add 3 operands between these two separators. So the first operand will be your condition, and the condition is if a is greater than 6. And second operand will be if this condition is true, what you want to do? We want to assign the value of a to value of b. So here I have written a. So it means, so if this condition returns true, it will return the second operand, and if this condition return false, it will return the third operand, and inside third operand I'll pass the else block, that is b equals to 0. Okay, now I'll save the changes, and you can see the same output, that is 0. And if I change the condition, a is greater than 4. Now save the changes. This time you can see the output 5, because here we have initialized the variable a with 5 and 5 is greater than 4. This condition returns true. That is why it will print the second operand, that is a. And if this condition returns false, it will print the third operand, that is 0. So if we compare this ternary operator with if else statement, the first operand is a if condition, second operand is if block value, and the third operand is else block value. So instead of this if else block, we can use ternary operator, and with the help of ternary operator, we can reduce the number of lines of code. Okay, so this is all about the ternary operator. I'll comment out this code, and now we will move on to the next operator, that is concatenation operator, and it indicates with plus symbol. The concatenation operator is used to join 2 or more strings into one single string. So here I'll declare one variable with keyword let, and the variable name is first name of type string equals to, I'll assign value Sanvi, and I'll take one more variable with name last name, and I'll assign value to last name is Patil. Now I want to concatenate these two variables. Okay, so I log these two variables inside console.log. Here I'll take first name and then last name, and between these two variables I'll use the concatenation operator, that is plus symbol. Okay, now save the changes and I'll run this file. You can see the output Sanvi Patil. And if you want the space between the Sanvi and Patil, then you can concatenate the space like inside quotes. You just need to add one space, and now save the changes, and you can see the output Sanvi Patil. So this is how we can join 2 or more strings into one single string. So I'll comment out this code again. And now let's understand the last operator, that is type operator. And these type operators are used with objects such as type of operator, instance of operator, in operator, and delete operator. So first we'll see the type of operator. So for type of operator, I'll declare one variable with name, cname of type string, and I'll assign value to the cname is FED learning. Okay, and I'll log this cname. So in this case, we will get output FED learning. But if you want to know the type of this cname variable, then you can write here type of operator and then variable name. Now this time you will get the output string, because the CNAME variable is a type string. So if you not assign the type to the variable, then also you can find out the type with type of operator, that is string. So this type of operator is used to get the type of variable or expression at compile time. And it will decide the type of variable as per the value which we have assigned to that variable. So we have assigned string value to the CNAME. That is why this type of operator returning string. Now next is instance of operator. I'll pause the video and I'll write down the code for instance of operator. So here I have written an example for instance of operator. So first we'll see what is instance of operator. So this instance of operator is used to check if an object is an instance of a particular class or a constructor function. It returns a boolean value true or false. So here I have written one class with name animal and the second class with name dog, and this dog class extends animal class. Okay, and inside this dog class I have written one method with name bark. So after that, here I have created an object with name dog, and after that I have written two console log. First console log I have written for animal class. Is this dog object instance of animal class? Or second console log I have written for dog class. Is this dog object is an instance of dog class? So here I'll run this file and you can see the output true and true. So both console is returning true because this dog class extends to the animal class. That is why this dog object is an instance of animal class as well as dog class. Okay, so this is how we can use the instance of operator. Now let's see an example of in operator. So what is the use of in operator? In operator returns true if the specified property is contained in the specified object. So in order to use in operator, we need one object. So here I'll create emp name object and equals to, I'll assign the properties inside that object with key value pair. So the key is fname colon value is Vishal and next key is lname colon value is Patil. Okay. So this object we have created for in operator. So now what we have to do? With the help of code, we need to check this fname property is containing in the employee name object or not. So for that here inside log I'll use in operator. So before this in operator we need to add the property name. So here I'll add fname and after this in operator I have to write the object name. So the object name is employee name. So it means this in operator will check this fname property is containing inside this employee name object or not. So here I'll save these changes and I'll run this file. You can see it's true. If I change it to lname, then also we will get output true. And if I change it to name, now this time we will get output false. See, we are getting false because this name property is not containing in the employee name object. So it means this in operator, it returns true if the specified property is containing in the specified object. If not, it will return false. So I'll comment this console and now let's understand the next and last operator, that is delete operator. The delete operator used to remove a property from an object. So here for delete we will use same object, and if you want to delete any property of this employee name then you can make use of delete operator. For example, here I want to delete the fname property, then I can write here delete space object name, that is employee name dot property name, that is fname, and after that I log employee name. Now you can see once I run this file, the fname property will get deleted from employee name object. After that, we have written employee name inside log. So we will see the updated object as well. You can see. So now this time the emp name object is holding only one property, that is lname with value Patil. So that's all about the TypeScript operators.
Now let's dive into TypeScript functions. and we will cover the key concepts and features. So let's start with function definition. A function is a block of reusable code that performs a specific task. It takes optional input and can optionally return a value. So TypeScript functions are the building blocks of readable, maintainable, and reusable code. In TypeScript function, there are the concept of function type. A function type has a two parts, parameters and return type. When declaring a function type, you need to specify both parts. Like in this example, you can see x and y are the parameter of function with the type number, and the type of the return value is number, and that follows the fat arrow appeared between parameters and return type. So the syntax is function followed by function name and followed by parenthesis, and inside parenthesis now we can pass the parameter along with data type, and then we can provide the return type of that function and then function body. Next, we will see the function parameter modifiers. In TypeScript, there are many parameter modifiers to modify the behavior of function parameters. But in this video, we are going to see these three function parameter modifiers. So the first parameter is rest parameter. It allows a function to accept an indefinite number of arguments as an array, and it's denoted by 3 dot followed by the parameter name. Like here, you can see we can pass parameter as a rest parameter, so that while calling the same function, we can pass as many arguments as we want. Next parameter is default parameter. It assigns a default value to the parameter if it's not provided. It means a function parameter that is assigned a default value if no value or undefined is passed to it when the function is called. And it's denoted by equal to. Here in this example, you can see we can pass the value hello to this name parameter. Name of type string equals to hello. Now let's understand the third parameter, optional parameter. It indicates that the parameter is an optional and can be omitted. It means a function parameter that doesn't have to be provided when calling the function. You can mark a parameter as an optional by adding a question mark after its name in the function definition. Like here, you can see name is a parameter, and we can make this parameter as an optional by adding the question mark after the parameter name. Next, we will see the concept of function overloading. Function overloading allows us to define multiple functions for a single function and provide one implementation that handles all defined signatures. And here you can see the examples, function, function name, and here we are passing two parameters, x and y, along with the data type number, and this function will return a value of type number. So this is a return type and this is a parameter type. And the second example is also for the add function, but here we are passing parameter x and y with different data type like string, and this function will return the value of type string, and this is called as overloaded signature. So this overloaded signature enables us to provide different implementations of a function based on the arguments passed in. So the function overloading allows us to define multiple function signatures with the same name but different parameter types. So this is all about the theory of TypeScript function. Now let's jump into the Visual Studio Code and we will continue from there. But before we start practical, kindly subscribe to FAD Learning for more useful content. Your support means a lot to me. Thank you. So here inside Visual Studio Code, I'll create new file with name functions.ts. So how to write a function in TypeScript? To begin, just as in JavaScript, TypeScript functions can be created both as a named function or as an anonymous function. So to quickly recap what these two approaches looks like in JavaScript. Now let's write the code for adding two numbers. First I'll write the example of named function and then we will convert it to an anonymous function. Okay, the function followed by function name add, and I'll pass two parameter x and y, and after that function body, and I'll return the addition of x and y, x plus y. Okay, so this is how we can write the named function in JavaScript. And now I'll convert the same function into an anonymous function. So here what I'll do, I'll just remove the name of function and I'll put this function into one variable. So let addition equals to the same function. So here I'll hide this explorer as well as this terminal, and now you can see in JavaScript we can write named function like this and anonymous function like this. But now we are going to see the functions in TypeScript. So in TypeScript we need to provide the type of this parameter. So here I'll copy the same function and I'll paste it one more time. And this is TypeScript named function. So here I'll change the name to sum, and here we will keep add. So here we need to pass the type of this x parameter, that is number, and the type of y parameter is also number. And after that we need to provide the return type of this add function. So it will return the value of type number. So that is why the return type of this add function is number. And now how we can call this named function? We can call this name function with name of the function, that is add. And here we need to pass two arguments, 2, 3, because in the function definition we are passing two parameters x and y. So now save the changes, and here I'll run this file with command node space functions, and you can see the output 5. 2 plus 3, 5. From the same function we can convert it into an anonymous function by removing the name of function and assign this function to another variable, like let addition of two numbers equals to the same function. And now while calling the anonymous function we need to call the variable like function expression. Now you can see in this case also we will get same output 5. So we have seen named function as well as anonymous function in TypeScript. So I'll remove these JavaScript functions and I'll keep TypeScript named function. Okay. So here again I'll convert it into the name function with function name add. Okay. So in this example, the add function accepts two parameter x and y with type number. And if no parameter type is defined, then TypeScript will default to use any. Therefore, it is important to add type annotations to a function as much as possible. Now, this colon and number after this parenthesis indicates the return type. So in this case, add function returns a value of the number type. And when a function has a return type, the TypeScript compiler checks every return statement against the return type to ensure that the return value is compatible with it. And if the function doesn't return a value, you can use the void type as the return type. So when you call the add function, the TypeScript compiler will check each argument passed to the function to ensure that they are numbers. So in this example, we can pass only the numbers, not the values of other types. For example, if I pass this string values, this will result an error because it passes two strings instead of two numbers. Here you can see the error argument of type string is not assignable to parameter of type number. So we can't pass the argument of different type. Okay. So in short, we can write a function in TypeScript is similar to JavaScript but with added parameters and return type. And note that any JavaScript function is a perfectly valid TypeScript function. However, we can do better by adding type. Now, in JavaScript, all parameters are optional and default to undefined omitted. But in TypeScript, we can make a parameter optional by adding a question mark after its name. So what I'll do, I'll copy the same function and I'll paste it under optional parameter. Okay, and I'll comment out this name the function. Okay, so by default, TypeScript will assume all parameters are required, but they can be explicitly marked as optional. So to make a function parameter optional, we use the question mark after the parameter name. Like if I want to make this y second parameter optional, then I can add a question mark after the parameter name. So now in this case, we can pass only one argument to the add function because we have made the second parameter as optional by adding question mark. So in TypeScript, the compiler checks every function call and issues an error if the number of arguments is different from the number of parameters specified in the function, or the types of arguments are not compatible with the types of function parameter. But in this example, we have made the second parameter as optional. That is why we are not getting any error. And one more thing about optional parameter is the optional parameters must appear after the required parameters in the parameter list. Now, next in TypeScript, we can set a default value for a parameter using the equal to operator. And this value is used if the user doesn't provide one or passes undefined. And this is called as default parameter. So let's see the example. So I'll copy same example and I'll paste it under default parameter. And I'll comment out the example of optional parameter. And here I'll remove the question mark and instead of that I'll add equal to symbol and I'll pass the value of this y parameter is 3. Okay. So the default value goes after the type annotation. Means the type of y variable is number. After that we can add equal to operator and we can assign the value. And this parameter also come after all required parameters are treated as optional. And just like optional parameters, it can be omitted when calling their respective function. So in order to call this function, here also we can pass only one argument. So here I'll save the changes and you can see the output 5. 2 plus 3 equals to 5. And if you pass the second argument as well, like 5, then in this case, this second argument will override to this value. And now we will get output 5 plus 2, 7. So the use of this default parameter is if we are not passing the argument while calling the function, then it will consider the default value and return the result. And if you placed this parameter before the required parameter like this, then we have to pass undefined explicitly to use the default value. So here instead of 2, we need to pass undefined. Now next is rest parameters. Here required, optional and default parameters are focuses on single parameter. But what about multiple or unknown parameters? In this case, TypeScript offers REST parameters. So REST parameters can be typed like normal parameters. So here I'll write function followed by name of the function, calculate followed by parenthesis, and here I'll pass the REST parameter and it denotes with 3 dot with name nums with type array of number and it will return a value of type number. And then function body. And inside body, I'll declare one more variable with name total equals to I'll assign value 0. And after that, here I'll use for each loop dot for each variable num arrow symbol and then total plus equals to num. And now I'll return total. Okay. So this is how we can pass the REST parameter to the TypeScript function. So as I said, REST parameters can be typed like normal parameters, but the REST parameters follow some rules like a function has only one REST parameter and the REST parameter appear last in the parameter list. Like if I want to pass any other parameter, then I have to pass it before REST parameter like this. So the first rule is function has only one REST parameter and the second rule is the rest parameter appear last in the parameter list. And the third rule is the type of rest parameter is an array. So these three rules we have to follow while using rest parameters. And in this example, this calculate method calculates the total of numbers passed into it. Since this nums parameter is a rest parameter, we can pass one or more numbers to calculate the total. Now I'll call this calculate method inside console.log with no argument. Now save the changes and let's see the output. Here you can see we are getting 0 output. And if I pass two argument 5, 10, then this time we will get output 5 plus 10, 15. And if I pass three argument 5, 10, 20, then this time we will expect the output 20 plus 10 plus 5, 35. You can see we are getting expected output 35. So it means with the help of rest parameter, we can pass as many arguments as we want. But this rest parameter example of single type, that is number, and if you want, TypeScript allows us to handle rest parameters with multiple types using union types. So for example, if you want to pass the argument of type number as well as string, then we have to use pipe symbol and you can add the type. So in this case, while calling the function, we can pass the argument of type number as well as string. Okay. So I'll delete this string and we'll keep this with number type only. Okay. So the benefits of rest parameter in TypeScript is it handles multiple or unknown parameters. It allows 0 to many optional parameters and it store arguments in one variable. Okay. Now let's move on to the next point, that is function overloading. In JavaScript, we cannot overload a function, but let's see how we can overload a function in TypeScript. Okay, so what is the definition of function overloading in TypeScript? I had split the definition of function overloading in these 3 points. First is multiple methods having same name. Second is different parameter types and return types. And third is number of parameters should be the same. So it means the definition of function overloading is multiple methods having a same name but different parameter types and return type. However, the number of parameters should be the same. So as per these 3 points, I'll create one function twice. Like function name is sum. So here also we are going to do the addition of two numbers followed by parenthesis, and here again I'll take two parameter a of type number comma b of type number, and it will return a value of type number and then function body. Now what I'll do, I'll copy the same function and I'll paste it here. Okay, but in the second function I'll change the type number to string and this function will return value of type string. Okay, so here in the definition you can see multiple methods having same name, means here we have written two methods having same name, sum and different parameter types and return type. So here we have provided the different type. This is of type number and this is of type string. And the third point is number of parameters should be the same. So here also we are passing two parameter and here also we are passing two parameter. So here we have written function as per the definition, but still we are getting an error because in order to overload the function in TypeScript, first we need to provide the overloaded signature and then we have to write the implementation of overloaded signature. So before this function definition, first we have to write the overloaded signature. And how to write overloaded signature? An overloaded signature means we can create function without function body. That means I'll copy this function and I'll not provide the function body. Instead of that, I'll add semicolon. So similarly, I'll copy paste this line and the second signature is of type string. Okay. So now this is our first overloaded signature and this is our second overloaded signature. Now we have to write the implementation of this sum function. So here we have written two overloaded signature, but we need to implement this only once. So like here we need the implementation only once. And here instead of number we have to provide the type of any, because this implementation is for type number as well as type string. So we can provide the parameter type as well as the return type as any. So this is called as overloaded signature and this is called as signature implementation. So now inside this function, we have to write a common logic for these two overloaded signatures. So here I'll return a plus b. Now you can see I'll call this sum function inside console.log. Here I'll call this function for first overloaded signature. So the first overloaded signature will return number. So here I'll pass two numbers 5, 10, and similarly I'll call the sum function one more time for second overloaded signature, and second overloaded signature will return a value of type string. So here I'll pass two string, one is fed and another string is learning. Now save the changes and rerun this file. You can see we are getting output 15 and fed learning, 10 plus 5 15, and fed plus learning fed learning. And if in case I pass the value number and string, then you can see we are getting an error, because we can pass the argument as per the overloaded signature. If you want to pass the argument of type number as well as string, then we have to write one more overloaded signature of type number and string, and it will return of type any or both. We can add number, pipe symbol and string. Now save the changes and rerun this file. Here you can see 15 FAD learning and 5 learning. So I repeat, this is called as overloaded signature, and we define multiple function signatures, each with a different set of parameters and a different return type. These signatures act as a public interface of the function, and this is called as signature implementation. We provide a single implementation for the function that handles all the defined overloaded signatures. This implementation must be compatible with all the overloaded signatures. Okay, so that is all about function overloading. So under TypeScript functions, we have covered type annotations. It means TypeScript allows us to specify the types of parameters and return values, improving code readability and maintainability. Next, we have seen default parameters. We can assign a default value to the parameter if it's not provided. Next parameter, we have seen optional parameters. We can define optional parameters by adding a question mark after the parameter name. And the third parameter, we have seen rest parameters. We can use rest parameters to represent an indefinite number of arguments as an array. And last, we have seen function overloading. TypeScript allows us to define multiple function signatures for a single function, enabling it to handle different combinations of parameter types.
Now let's understand about classes. First, we will start with definition. Classes are blueprints for creating objects. They encapsulate properties and methods into a single unit. And classes provide the features of object-oriented programming, so it makes our code more usable, maintainable, and scalable. Okay, so these three are the key concepts of classes in TypeScript, such as properties, methods, and constructor. Properties are variables that hold data associated with the class. Methods are functions that belongs to the class or object, and they are used to perform specific actions or operations on an object data. And last is constructor, is a special method that initializes an object when it's created. And here you can find the syntax of class. we need to use class keyword to define a class in TypeScript, and class followed by class name and then open and close curly braces, or we can say the body of class. And inside class, we can declare properties and method associated with that class. Also, we can make use of constructor to initialize the object's properties. Next, we will learn about access modifiers. Access modifiers control the visibility and accessibility of class members, and class members are nothing but properties and methods. So there are three main visibility modifiers in TypeScript: private, public, protected. Private only allows access to the class member from within the class. So the members declared as private are only accessible from within the class itself. Next is public. This is a default modifier, allows access to the class member from everywhere, or we can say members declared as public are accessible from everywhere, both inside and outside the class. And third modifier is protected, allows access to the class member from itself and any classes that inherit it. Means members declared as protected are accessible from within the class and its subclasses. And we can use one more property with variable inside class, that is read only property. It is declared with read only keyword, and read only keyword can prevent class members from being changed.
Means it cannot be changed or modified after its initial assignment. In TypeScript class, a read-only property is a property that can be set during declaration or in the constructor, and it cannot be modified after object creation. So here you can see that we can use the read-only property when declaring a class level variables or apply the read-only modifier to a constructor parameter. Okay, so now let's switch to Visual Studio Code and we will explore each of these points with practical examples.
So inside Visual Studio Code, let's create new file with name classes.ts. So the TypeScript supports object-oriented programming language, and class is one of the concept in object-oriented programming. So here, as per the syntax, let's create a new class with name person in TypeScript. Class followed by class name, person, and open and close curly braces. Or we can say body of the class. What are the things we can write inside the class? So class is a combination of three key components. First is properties to store data, and second is methods to perform action, and third is constructor to initialize object. Okay, so class is the combination of these three elements like properties, methods, and constructor. So first we will write the properties of person class. Properties means a person has attributes such as first name, last name, age, and many more. In the person class, we define these attributes as properties using variable declaration like f name of type string, next L name of type string. So here I have declared two properties or variable for the person class. Next, I'd like to add one method. Here, methods are essentially functions that belongs to a class. So, when we create function without class, we can simply call as a function. Whereas, when we create same function inside the class, then it is called as method. So, method is nothing but function. If you create the function inside the class, then it is called as method. And if you create a function outside the class, then it is called as function. That's it. So here I am creating function inside class. That is why I am going to call this function as a method. And the name of method is get full name. And this method will return nothing. So I'll write void, and void is nothing but it doesn't return anything. And then body of the method. And inside body, I am going to print these two variables. So I log these two variables inside console.log. Now how to access these variable inside this method. If I write here fname, then you can see we are getting error, cannot find fname, because this fname is a class level variable. We have created these two variables inside class, so it is called as class level variables. And how to access class level variable inside method? We can access class level variable inside method with this keyword, this dot fname. Okay, I repeat, if I remove this keyword, now access is no longer available because this variable is created at the class level and we can declare them globally. So these variables cannot access inside method. So to access this variable inside method, I need to use this keyword. So in this case, this keyword is representing the class. So this dot fname means from this person class, I am referring the fname. Okay. So as I said, class is the collection of variables, methods, and if needed, we can add constructor as well. And we will proceed to this constructor in few minutes. So as of now, we have written two variables and one method under this person class. Now, in order to access the variables and methods of any class, we need to create an object of the same class. So unless we create an object for this class, we cannot access the variables and methods of a person class. Okay, so now what is an object? Once we create a class, we can create multiple objects for that particular class. So the object is nothing but an instance of a class. And why do we need to create multiple objects of a same class? Because each person has unique properties and behaviors. Properties are nothing but variables, and we can describe behavior in the form of methods. So for example, person A has a distinct name, age, and behavior, whereas person B has a different name, age, and behavior. So each individual person is having their own properties and behavior or methods. This is the reason we can create multiple objects from the same class. So with the help of object, we can create an instance of the class. So now how to create an object? We can create an object with new keyword. New followed by class name, person, and then parenthesis like this. And after that, we need to assign this object to one variable like var p1 equals to new person. And this variable is called as object reference variable because this variable is referring to this object. And this object we have created for the person class. Okay, so now p1 is our object reference variable. Now with the help of p1, we can access the properties and methods of person class. Because when an object is created, memory is allocated for a new instance. So now through this p1 object, I can access all variables and I can assign values to them. And after that, I can call get full name method through the same object and I can print the values of variable. Like here, if I type p1 dot, you can see now we are getting access of fname variable, lname variable, and get full name method. Here you can see fname is a property, get full name is a method, and again lname is a property. So now I'll take first fname and I'll assign value to fname is Vibha. Similarly, I'll assign value to lname equals to Patel. And now I'll call the method with same object reference variable, that is p1 dot get full name, and this method will print the values of fname and lname variable. Okay, so here inside console.log, I'll add the lname as well, space, and here this dot lname. Okay, so before run this file, I wanted to discuss about class and object. So this class is a logical entity, whereas this object is a physical entity. Class is just a blueprint, and based on this, we can create multiple objects. So we can create any number of objects for one class. Like here, I can create one more object with name P2. So here, once we create a new object, memory is allocated for a new instance. So in this case, for P1 and P2, separate memory is allocated. But these two objects are independent even though these objects are derived from the same class. Like this P1 object is derived from person class and P2 object is also derived from person class. But both objects are independent. Okay, I repeat, the class is a logical entity and a object is a physical entity. Class contains variables and methods, and whichever objects are derived from the class, every object will acquire their own copy of variables and methods. For example, for this P1 object, F name is Vibha and L name is Patel, but for this P2 object, properties are same like F name and L name, but the values will be different. So this is the basic concept of class and object in TypeScript. Okay, so I'll comment out this P2 object, and this is how we need to create an object, and through this object we can access the variables and assign values to them, and then we just need to call the method which will print the values of variable. Now let's compile this file to JavaScript and then we will run this file. So I'll open terminal and here I'll write command tsc ---- watch. I'll compile this file on watch mode. And now I'll open one more terminal and here I'll hit command node space classes. Enter. And here you can see output Vibha Patel is generated by the get full name method of the P1 object. Okay. In TypeScript, we can assign values to variable with three different ways. And this is the first way. We have assigned values through object variable. So here I can write the comment assign values through object variable. And I'll delete this P2 object. Okay. Now let's understand the second way. We can also assign the values to the variable by using the method. Okay. So this is first way. Now I'll copy this comment and I'll paste this here. This is the second way. Assign values through method. So here I'll create one more function or one more method with parameter. So I'll give name, set full name, and I'll pass two parameter. First name of type string and last name of type string, and then body of the method. And this function is also return nothing. So I'll write void. Void means doesn't return anything. So here we have passed two parameters, and while calling this same method, it will take two arguments. So in order to call this method through object reference variable, we need to pass two arguments because these two are required parameters. And these two parameters are called as local variable of this method. Okay. So this first name and last name are the local variable for this set full name method, but this F name and L name are the class level variables. So inside this method, what we will do, we will assign the values of local variable to the class level variable. And how we can access the class level variable? With the help of this keyword. This dot F name equals to first name. Similarly, this dot L name equals to last name. Now the values passed through the set full name method will be assigned to the class level variables. And here I have provided the different name to class level variable and local variable for our understanding. But if you want to use same name, then you can. Okay. Now I'll call the same set full name method through object reference variable, that is P1. So here instead of assigning this value through object, I'll assign the value through set full name method. like p1 dot set full name, and this method accept two arguments, first name and last name. So here I'll pass same name Vibha, comma Patel. Now when we save this file, the set full name method will be called immediately from the person class, and the argument passed to this method will be assigned to the class level variables. Subsequently, using the get full name method, we can display these values on the console. Okay, so here you can see after the set full name method, we have called get full name method as well. Now again I'll open terminal and rerun this file. You can see we are getting same output Vibha Patel. But this time we have received the values from set full name method. Okay, so we have seen first way of assigning values through object variable. Also we have seen the second way assign values through method. Now let's understand the third way, that is initialize variable using constructor. So here I'll copy the same comment and I'll paste it after this constructor. And this is third way. Assign values using constructor. And most of the time we use this approach for assigning values to the variable. So how to create constructor? Constructors are similar to methods. I'll cut this constructor and I'll paste this before method. Okay, so here what I'll do, I'll just copy this same set full name method and I'll paste it here, and instead of set full name I'll just write construct and I'll comment out this set full name method, and also I'll delete this return type void. That's it. So the constructor can create with constructor keyword, and like method here also we can pass the parameters which we passed to set full name method, and inside constructor again we are assigning the values of local variable to the class level variable, same like set full name method. So what is the difference between method and constructor? Constructor name should be constructor, and constructor doesn't return any value, not even void, and constructor can be defined with or without arguments. So constructors are similar to methods, but with a key difference. Constructors are called automatically when creating a class object, so that we don't need to call the constructor explicitly, whereas methods require explicit calls through the object. Now you can see here we are getting an error, and the error says expected 2 arguments but got 0, because when we create an object, the constructor is called automatically and the constructor expects 2 arguments. However, we haven't provided any during object creation. Therefore, we must pass 2 arguments while creating an object for a person class. So what I'll do, I'll copy these 2 arguments and I'll pass here, and I'll comment out this line number 31. Okay, so this is the advantage of constructor if you are comparing with method. We don't need to call constructor explicitly. It will call automatically once you create an object for that class. Now again I'll open terminal and I'll rerun this file, and you can see the same output Vibha Patel. Okay, I'll minimize this file, and we have seen the concept of class as per the definition. Like class is a collection of properties, methods and constructor. And also we have seen 3 different ways to assign the data through object reference variable, through methods and through constructor. Now let's use the read only property with new variable. So here what I'll do, I'll create one more variable with name age of type number, and I'll declare this property as a read only property. Okay, so the read only property must be initialized as a part of declaration or in the constructor of the same class. So I can declare the read only property here while declaring variable, or I can declare the read only property in the constructor of same class. So here inside constructor also you can pass like this: read only age equals to number. And here we need to pass this dot age equals to age, like this. And when a property is declared as read only, its value cannot be changed once the object is created. So here you can see we are getting an error while creating an object, because now in this case this object is expected 3 arguments but got 2. So here we need to pass the age as well. We are getting Vibha Patil only because we have consoled only F name and L name. So here I'll console the age as well. And now you can see output 20 Vibha and Patel. But since this is a read only property, if I try to reassign the value to age, like here p1 dot age equals to 30, here you can see we are getting an error. Cannot assign to age because it is a read only property. Here we have mentioned this age to a read only property. So in this example, the age property is marked as read only. This means it can only be assigned a value during the object initialization, either in the constructor or directly in the property declaration. It cannot be modified later. It will cause compile time error. Okay, so this is all about read only. Now let's talk on access modifier. So here I'll just remove this read only property and we'll see the example of access modifiers. Okay, so the access modifiers change the visibility of properties and methods of a class. And as I said, TypeScript provides 3 access modifiers: private, public, and protected. So first we will see public. So here I'll mark this age property as a public. And what is the definition of public modifier? The public modifier allows class properties and methods to be accessible from all locations. And if we don't specify any access modifier for properties and methods, they will take public modifier by default. So here you can see that if I mark this age property as a public, or if I mark this method as a public and I save the changes, here you can see declaring this method and variable as a public does not alter the behavior. We are not getting any error. It is working as expected. Here I'll rerun this file again and you can see we are getting same output, 20 Vibha Patel. So the use of public modifier is the public methods and properties will be accessible from all locations. Next we'll see the private modifier. And the definition of private modifier is private modifier limits the visibility to the same class only. When we add the private modifier to the property or method, we can access that property or method within the same class. And here you can see that declaring the f name and this get full name method as a private, it prevents access from outside the class, resulting in an error. You can see property get full name is private and only accessible within class person. And here you can see if I try to access the private variable f name, we are getting same error, like property f name is a private and only accessible within class person. So we can't access the private variable and methods outside the class. So I'll just remove this private modifier from method. Okay. So now the third modifier is protected modifier. The protected modifier allows properties and methods of the class to be accessible within the same class and subclasses. So we will see an example of protected modifier while learning the concept of inheritance. So except protected modifier, we have seen public modifier, private modifier. Also we have seen read-only property, and before that we have seen about classes and objects. And also we have seen how to pass the values to class level variables.
Now let's understand the concept of inheritance. A definition of inheritance is a class can reuse the properties and methods of another class. This is called as inheritance. So in this example, I have a parent class with defined properties and methods. Properties are nothing but variables and methods are nothing but functions. And to avoid duplicating code, I want to utilize the same properties and methods in a child class. So if I write same properties and method inside child class, as you can see, writing the same code in the child class would result in duplication. So therefore, instead of writing the same code in the child class, I can inherit the properties and methods from parent class through inheritance by extending the parent class. So we can say inheritance is a fundamental concept in object-oriented programming that allows you to create new classes based on existing classes. So inheritance is a mechanism for creating new classes based on existing ones, inheriting their properties and methods. And inheritance is implemented using extends keyword. So here class parent is an existing class and class child is a new class. And this child class is derived from parent class. So to reuse the stuff from parent class, a child class needs to extend the parent class. Like class child extends parent. And extends keyword is used to establish the inheritance relationship between classes. So here child class is called as new class or derived class or subclass. And parent class is called as existing class or superclass or base class. A class which inherits the properties is known as child class, whereas a class whose properties are inherited is known as parent class. Now next, let's understand the concept of static properties and methods, and it belongs to the class itself, not its instances. So here you can see some differences between static properties and static methods. So first we'll see the definition. Variables defined within a class using the static keyword, whereas functions or methods defined within a class using the static keyword. Next we'll talk on access. We can access variables and method directly on the class, not on instances of the class. Next is purpose. Static properties typically used for storing data shared across all instances of the class, whereas static methods used for utility functions related to the class or operations that don't require access to instance specific data. And here you can see the example of static property. Here I have declared one static property with name count of type number, and I have initialized this count equals to 0. So since this is a static property or static variable, so I can access this static property anywhere in the program with class name like counter.count. So in order to access the static property, I don't need to create an instance of a class. Similarly, for method, here you can see I have declared one static method with name add, and I have passed two parameters x and y, and inside this method we need to write the logic for addition of x and y. And in order to call this static method add, again I can make use of class name like addition.add, and I'll pass the argument x and y. With this static method as well, I don't need to create an instance of the addition class. So it means to access static properties and methods either within or outside the class, we can use the class name directly without creating an object. However, to access non-static members, we must create an instance of the class. Now let's switch to Visual Studio Code where we will explore inheritance and static properties and methods with hands-on examples. So inside Visual Studio Code, I have already created a file with name inheritanceexample.ts. Also, I have compiled this project in watch mode. So here you can see after compilation, the .js file is generated. So now here, first I'll create the class with name parent, class parent, and then body of the class. And class contains properties, methods, and also constructor. So here I'll declare two properties, first name and last name. First name of type string and last name of type string. After this, I'll create a constructor to initialize the value into these two variables. So constructor, and here I'll pass two parameters, fname of type string, comma, lname of type string. Okay, so this is how we can create a constructor. As I said, constructor is used to invoke at the time of object creation, which is used to initialize the values of variable. Now I'll assign the value of constructor parameter to the class level variable, and how I can assign the class level variable with the help of this keyword. This dot first name equals to fname. Similarly, this dot last name equals to lname. So this is our parent class. Now I want to create another class called child class. Okay. So since this child class also requires the same variable first name and last name and same constructor as the parent constructor. So instead of duplicating the code, I'll extend the parent class with extends keyword. Extend parent. Okay. Now what happens is that any variable and constructors belongs to the parent class are automatically inherited by the child class. Moreover, any additional variables and methods you create in the parent class will also be inherited by the child class. So now at this stage, the first name and last name variable and the constructor of the parent class belong to the child class as well. Additionally, I want to create another variable and constructor. So first I'll declare one variable with name job title of type string, and then I'll create one constructor. And here I'll pass three parameters. First name of type string, comma, last name of type string, and last job of type string. Okay, so this new constructor will require three parameters, first name, last name, and job, which I'll retrieve from the user and assign to class level variables. And here we can see the error. Constructors for derived classes must contain a super. So here what we need to do, we need to pass the first name and last name values to the super class or parent class constructor, and to do this we use the super keyword. Super, and inside super we need to pass first name and last name. First name, comma, last name. Okay. So this statement invokes the immediate superclass or parent class constructor. This allows us to pass the first name and last name values received from the user to the superclass constructor using super. And then after this super statement, we'll pass the job parameter value to the class level variable job title. This dot job title equals to job. And note that this statement must be the first statement within the subclass constructor. If I shift this super statement below, then you can see the error. Super must be called before accessing this in the constructor of derived class. So this statement must be the first statement within the subclass constructor. So far we have created one parent class and one child class which extends parent class. Now I'll create one method in a parent class which print the values of first name and last name. So here I'll create one method with name getFullName of type string, and inside body of this method I'll return this is first name and last name. This is dollar first name space dollar last name. Okay, now in order to see the values of this first name and last name variable, when I create an object of this parent class, I can only access parent class members, including properties and methods. However, when I create an object of the child class, I can access both parent class members as well as child class members. Okay, then I'll create an object of a child class, var child equals to new child. Now we can access the members of both classes, parent as well as child. Here you can see expected 3 arguments but got 0. Since we are passing 3 parameters to this constructor, when creating an object, it will expect 3 arguments. So here I'll pass fname, Sushma, lname, Patil, job, front-end developer. Okay. So internally what happens is this first argument Sushma will be assigned to the first name, and then this first name sends the same value to the superclass constructor fname, and which reassigns the same value to the superclass variable first name. And the same process occurs with the second argument Patil. And last, the third argument value front-end developer will be assigned to the third parameter of the constructor, that is job, and the same value will be reassigned to the class level variable, that is job title. Okay, so this is how we have created one parent class and one child class that inherits from the parent class, and then we have created an instance of a child class. But here we can have n number of child classes for a single parent class. Like here I can create one more child class like child1, and this child1 class also extends the same parent class. So it means we can have n number of child classes for a same parent class. Okay. Now to display the output of this getFullName method, I'll call the same method via object reference variable, that is child. So here inside console.log, I'll write child.getFullName. Save the changes, and now I'll open the terminal, and here I'll add one more terminal, and I'll run this file with command node space inheritance -example. You can see the output. This is Sushma Patil. So from this method, what we are expecting? We are expecting the output. This is Sushma Patil, and we are getting the expected output. Okay. So this is how we can access the members of a parent class from an object of a child class. Also, we can access the property of child class here. Instead of method, I'll call job title. Save the changes, and I'll again run this file. You can see output. This is Sushma Patil and front-end developer. So this is how, by creating an object of a child class, we can access the members of both class, parent class as well as child class. So now let's discuss one more concept in inheritance. Remember, when we learned about TypeScript functions, we also covered function overloading. And now let's understand how to override the method. So what is method overriding? Method overriding is the process when the method defined in the base class or a parent class is redefined by a method with the same name and signature in the derived class or child class. This allows the child class to provide its own implementation of the method, which can either extend or completely replace the behavior defined in the base class. So basically, whatever implementation is done in the parent class, if I change that implementation in the child class, which is called as overloading concept, because in the child class method may or may not use the logic defined in the parent class method. And as we have seen, to invoke the methods and properties of the base class, the super keyword is used in the derived class. This keyword helps in accessing the base class methods or properties within the child class. So here, after this constructor, I want to override this getFullName method which is present in parent class. So now let's understand the method overriding concept with two different examples. First is If you disagree with the parent class method implementation, then you can override it in the child class to provide an alternative implementation. So here I'll add comment basic method overriding. And second example, we will see method overriding using super. So it means if you want to extend or enhance the implementation of a parent class method, then also you can override it in the child class using super keyword. Okay. So under this example, what we are going to do, we don't want this implementation. We want to alter the implementation of same methods. So in this case, I can override the same method, get full name, and this method also return a string value. Because when I override this method, I should not change its definition. It means I must use the same parameters and return type. I can only modify the body of the method. So here I'll return different string like return I am a front-end developer. So here I'll bind the class level variable job title. Okay, so here what I did, I don't want this message. Instead of that, I want this message. And we are passing front-end developer value to this job title variable. So if you call this get full name method, now this time we are expecting the output. I am a front-end developer. Now save the changes and I'll rerun this file. Yeah, you can see I am a front-end developer. I'll comment out this line number 33. And here you can see the expected output. I am a front-end developer. Okay, so this is how we can override the parent class method into the child class. So hope you remember the concept of method overloading. In that, methods must have a same name and different signature. But in method overriding, methods must have a same name and same signature. So this is one of the difference between method overloading and method overriding. Okay, so in this method, we have completely changed the message or implementation of the get full name method. But now, in the second example, I want to display the same message along with the previous implementation, which is available in parent class. In this case, I can make use of a super keyword. So now, I'll comment out this example and here I'll again override the same method get full name with same return type. And here first I'll return the implementation of superclass get full name method and then I'll concat this message. So here I can use super keyword to invoke the superclass method super dot get full name and then I can concat the message I am a software developer like this. Now save the changes and open the terminal, rerun this file and this time you can see the output. This is Sushma Patil and I am a software developer. So this is Sushma Patil is coming from get full name method which is available in parent class and I am a front end developer is coming from get full name method which is available in child class. Okay, so method overriding is particularly useful when we want to alter the behavior of any method inherited from the parent class in the child class. Okay, so far we have seen the concept of inheritance as well as method overriding.
So now let's understand the concept of static members. Static members are nothing but static methods and static properties. And it belongs to the class itself, not its instances. So to understand the example of static members and properties, I'll create new class here with name counter. So here, first I'll create one property with name count of type number and I'll assign value 0. And now I'll create one method with name increment of type void and inside this increment method, I want to increment the value of this count variable. So as I told, this is the class level variable. So we can't access directly inside method. So in order to use class level variable inside method, we need to use this keyword, this dot count plus plus. So this method will increment the value of count variable. Okay. So this is how we can write class in TypeScript. So now I want to print the value of count variable, and in order to access the class properties and method, we need to create the instance of that class by using object. So here I'll create one object with name C1 equals to new counter, and now inside console.log I'll print the value of count variable with the help of object reference variable C1 dot count. Similarly, I'll execute the increment method by using C1 variable. And after increment, I'll again print the value of count variable. And here I don't want console.log because I just want to increment the value of count variable. Okay, now save the changes and I'll open terminal. And here I'll run this file with command node space static members. And here you can see we are getting output 0 and 1. So here I'll just write the text initial value of count and I'll concat this count variable. Similarly, I'll write the text for this count incremented value of count. Now I'll rerun this file and you can see the output. Initial value of count is 0 and incremented value of count is 1. So this is how we can write the normal class, and in order to print the data of class, we need to create an instance of that class. And then we can access the properties and methods of same class by using object reference variable. But now here we want to understand the concept of static members. So for that, what I'll do, I'll just use static keyword before this variable as well as before this method. So now this is not a class property. Now this is a static property. And this is not a normal method. This is a static method. And how to access the static variable? We can access the static variable with class name. So here instead of this, we can use counter.count. Similarly, if you want to print the count variable, you don't need to create an object for that class. You can directly add the class name, that is counter.count, and you can access the count property. So this is about property. And in order to access the method, here also instead of object reference variable, we can directly use the name of class, that is counter. Now I'll do the same changes for this console as well. And now I'll rerun this file. This time also you will get the same output. Here you can see initial value of count is 0 and incremented value of count is 1. If I run this method 2 more time, now in this case our incremented value of count will be 3. Now I'll rerun this file and you can see the initial value of count is 0 and incremented value of count is 3. So this is the benefit of static members. We don't need to create an instance of that class. So since no class instance is created, memory allocation is avoided. Okay. So what is the difference between static and non-static? And the answer is static means you can access the method over the class name without creating an object, and it is also accessible from an outer class. But without static, you need to create an object. So first we have seen the example without static properties and method, and then we have converted into static properties and methods. Now I repeat the definition of static properties and method. Static properties and methods are class members defined within a class using static keyword. And how to access static properties and method? To access static properties and methods, you don't need to create a class instance. Simply use them with the class name like counter.count and counter.increment. So now what is the benefit of using static properties and methods? By utilizing static properties and methods effectively, you can improve performance, enhance code readability, and you can promote code reusability. So hope you understand the concept of static members. We will explore the fundamentals of abstract classes. So let's start with the definition of abstract classes. Abstract classes in TypeScript are classes that cannot be directly instantiated and serve as a blueprint for derived classes. This means we cannot create object directly from an abstract class. So here is the example demonstrated the syntax of abstract classes. We can declare abstract class using abstract keyword, and abstract class contains one or more abstract methods, and this abstract method does not contain implementation. It only defines the signature of the method without including the method body. And this abstract method must be implemented in the derived class. So abstract classes are designed to be inherited by other classes, providing a foundation of implementing abstract methods. So this enables creating functionality that subclasses can implement or override. So here, parent class is an abstract class and child class inheriting the properties of parent class or abstract class. And we cannot create the object of abstract class. So in order to run this abstract method, we need to create the another class and extend the abstract class. And then we can create the object of subclass, that is child class. And with the help of object reference variable, we can call the abstract method. So now let's open Visual Studio Code and understand this concept with an example.
So here I'll create new file with name abstractclasses.ts. And then I'll compile this project in watch mode with command tsc-watch. It allows me to run the file with command node space abstract classes without manual compilation. So I'll run this file with command node space file name like abstract classes. So here you can see after compilation the abstract classes.js file is generated. Now here I'll create a normal class with name shape class shape and then body of the class. And class includes properties, method and constructor. So first I'll declare one property with name radius of type number. And this is called as class level variable. Okay. So next I'll create a constructor with one parameter. Constructor with parameter r of type number and then body of the constructor. And here inside constructor, I'll assign the value of r to the class level variable, that is radius, and we can access class level variable with this keyword. Okay, this dot radius equals to r. And now I'll create one method with name circle perimeter of type number. And inside method, I'll return the formula of circle perimeter, that is 2 pi r. Return 2 into math.py into this dot radius. So inside this shape class, we have written one variable and then constructor and then one concrete method. So now this is how we can write normal class in TypeScript. And now I want to convert this class into an abstract class. I can convert this class to an abstract class by using abstract keyword. So by using an abstract keyword before the class, we have made the normal class as an abstract class. However, this is not the correct syntax for an abstract class because an abstract class must have at least one abstract method. So here I'll define an abstract method without implementation. And how to write abstract method? We need to write abstract keyword first and then method name, circle area of type number and then semicolon. Because the abstract class only specify the signature of abstract method excluding method bodies. So now by adding an abstract method, we have successfully converted the normal class into an abstract class. But now to execute the properties and methods of this abstract class, if I create an object of this class like here let calculate equals to new shape. And here you can see we are getting an error and it says cannot create an instance of an abstract class because the shape class is an abstract class and we cannot create a new object from it. Instead, we can create object from the class who is inheriting this class. Okay. So what we will do? Here we will create a circle class circle, and that extends the shape class, inheriting its properties and methods. And here Instead of creating an object of a shape class, I'll create an object of a circle class. Now, inside the circle class, I'll define a constructor with a single parameter like R with type number, and within this constructor, I'll invoke the super keyword passing the constructor parameter R. Super, and inside that I'll pass this parameter R. And note that super must be the first statement within the subclass constructor. Now, after this constructor, we must provide the implementation of the abstract method. Like inside this shape class, we have written the signature of abstract method with name circle area. So the implementation must be written in the subclass of that abstract class. So here circle area of type number, and inside this method I'll return the formula for area of circle, that is pi r square. Math dot pi into radius, this dot radius into 2. Okay, so this abstract method must be implemented in the derived class. Here we are getting an error because this circle class expected one argument but got 0. So here I'll pass radius 3. Okay, and in this example, shape is an abstract class with an abstract method circle area, and the circle is a concrete class that extends the shape class and provides an implementation for an abstract method, that is circle area. And here we have created a circle class instance rather than a shape class instance. So in this case, the variable calculate serves as the object reference. And now we will invoke circle area as well as circle perimeter within console.log to display the result. So here I'll write calculate dot circle area inside console.log, and same I'll write for circle perimeter. Okay, I'll save the changes, and now I'll open the terminal and I'll rerun this file. And here you can see the output. This 28.27 is the area of circle, and this 18.84 is the perimeter of circle. Okay, so I hope you understood why we use an abstract classes in TypeScript. An abstract classes allows us to define base classes from which other classes can be derived, and they serve as a blueprint for other classes without direct instantiation. Okay, so I'll recap the key points about abstract classes. Abstract classes cannot be instantiated, meaning direct object creation is impossible. An abstract class has at least one abstract method, and to use an abstract class, we need to inherit it and provide the implementation for the abstract method. And an abstract classes can contain concrete members, including non-abstract methods and properties. And last, abstract classes utilize access modifiers, public, private, and protected. Like if I declare this property as a public, then it allows this class property to be accessible from all locations. And if I declare it to private, it limits the visibility to the same class only. So here you can see we are getting an error. Property radius is private and only accessible within class shape. So if I declare any property or method as a private, then we cannot access that property or method outside the class. And last is protected. And this protected modifier allows properties and methods of a class to be accessible within the same class and subclasses. So here you can see we can use this radius property within the shape class as well as in the subclass. We are not getting an error with radius with protected modifier. And same happen with methods. Okay, so that's all about abstract classes. Now let's learn about interfaces. In TypeScript, an interface is a way to define the structure or shape of an object, and it specifies the properties and methods that an object should have. And this is the syntax of interface. An interface is defined using the interface keyword followed by interface name, and it can include properties and method declarations using a function or an arrow function. To gain better understanding of interfaces, we will create a practical example implementing interfaces for objects and classes. Also, we will see the properties of interfaces like read-only, optional, and extends. Inside interface, we can declare property as read-only, and assigning a property as read-only prevents subsequent modifications, means once a value is assigned to a read-only property, it cannot be changed later. Next property is optional property. Using the question mark symbol makes a property optional, and optional properties are properties that don't have to be defined in the object definition. And the last property is extending properties. TypeScript supports interface inheritance, allows us to extend existing interfaces with new properties without losing existing ones. And an interface can extend one or multiple existing interfaces. Like here, child interface extending parent interface. Like if child interface wants to inherit all the properties and methods from the parent interface, then we can make use of extends property. Okay, so that's all about theory. Now let me open Visual Studio Code for a practical example.
Here I'll create new file with name interfaceexample.ts. So first we will see why do we need an interface in TypeScript. When declaring any variables in TypeScript, we specify their data types. For example, if I declare one variable with name fname of type string equals to John. So in this statement, fname is the variable name and string is the data type of this fname variable, and John is the value of fname. Okay, so this is how we used to declare the variable in TypeScript. Now let's create a user data object with first name and age property. Let user data equals to first name John, comma age 20. So here, if I try to specify the data type inside an object like first name is of type string, then you can see I'll get an error. So how can we define the data types of these two object values? So to define the data types of these two key value pairs, we utilize an interface. So for object and classes, interfaces act as a blueprint defining the types of their properties and methods. Okay, so I'll delete this property declaration, and here let's understand how to create an interface in TypeScript. Create an interface, we use interface keyword followed by the name for the interface. Here I am going to call an interface user and then body of the interface. And here we will follow the convention like when we create a class, the first letter of the class is in uppercase. In the same way, when we create an interface, we will keep the first letter of the interface name in uppercase. So just like how we create a class, we create an interface. The only difference is when we create a class, we use class keyword, and when we create an interface, we use interface keyword. Now inside this interface, we can declare the properties and methods, and interface should not contain the implementation, it should only contain the declarations. For example, here I'll declare the same properties in the interface as we defined in the object, first name of a type string and age of type number. So here you can see I am simply specifying a declaration. I am not assigning any values to these properties. If I try to assign a value to the first name property, like fname equals to John, you can see I am getting an error. An interface property cannot have an initializer. It means we cannot initialize the value inside interface because an interface should only contain the declaration. It should not contain any implementation. So this is called an interface and it serves as a type definition for any object or class. So now we can use the user interface as a type of this user data object like user data colon user. But inside interface, as I mentioned earlier, interfaces can include properties and methods. We have declared two properties first name and age. Now let's add a get data method which returns nothing. So I'll specify its type as void. And here we can also define parameters for the get data method if necessary. And one more thing, inside interface, when we declare a method, it should only have a declaration. It should not have the implementation. So implementation cannot be written inside an interface. And here you can see, as soon as I add a new property or method inside an interface, I'm getting error here. Property get data is missing in type, first name and age, but required in type user. This is because when using an interface as a type for an object, all interface members must have implemented in the object or class. So inside object, now I need to implement the get data method. And this method returns void. So here I log one message. This is John. Now, since we have specified the type of this user data object as a user, and when we are going to assign an object to it, that object must include the properties first name, age, and it also must contain the implementation for this get data method. However, we can utilize read only and optional properties. For example, we can use read only property for this age, like read only space age, and I want to make this first name property is optional, and optional properties are denoted by a question mark. Now, when a property is declared as a read only, its value cannot be changed once the object is created. Like here, if I try to change the value of this age, like here, user data dot age equals to 30. So here you can see it will not allow us to change the value of age. Cannot assign to age because it is a read only property. And if we talk on optional properties are properties that don't have to be defined in the object definition. So here we marked the first name property as optional by adding question mark after the property name. It means we can skip the implementation of first name inside the object, or we can choose to include or exclude optional properties in the object without resulting in errors. And if I remove this question mark, then I must have to implement this first name property inside user data object, because we have specified the type of this user data object as user. So to recap, we can use an interface name as a type for an object or a class. In an interface, we should only include declarations without any implementation. This means no implementation of properties and no definition of methods. Also, just like an abstract class, we cannot create an instance of an interface. But here, if we want to run the getData method, we can simply call it using object name. So here, inside console.log, I'll call this getData method with object name userdata.getData. That's it. Now save the changes and run this file. And here, if you notice, the interface example.js file has been automatically generated because I have compiled this project in watch mode, and the TypeScript compiler does not convert interfaces to JavaScript. Instead, it uses interfaces for type checking, which is why this approach is known as structural subtyping. Let's open the terminal, and here I'll add one more terminal and run this file with command node space interface example. And here you can see the output. This is John. Okay, so this is an example of an object using an interface. Now let's explore how interfaces work with classes. So for now, I'll comment out this object code and I'll create one class with name employee. This is a class name, so E should be capital, and then body of the class. So now in this class, let's define a constructor with first name and age property. Constructor public first name of type string, comma, public age of type number, and then body of the constructor. So this constructor creates and initialize first name and age properties, assigning them the values passed through the corresponding parameters. Now let's implement a method with name getData. GetData of type void, and inside method I'll log one message. Welcome to FED Learning. Okay. So here the employee class can be defined the first name and age properties along with the getData method. So now we will make this employee class implements the user interface, which will require the employee class to have a first name and age properties as well as a getData method. So here I'll delete this read only property for now. And to implement an interface for a class, we use implements keyword. And here we want to implement the user interface. So I'll write user. So now class employee implements the user interface. But here this employee class can include extra properties and methods not defined in the interface. It means here I can declare one more property like public ID of type number, and this property is not defined in an user interface. So it means I can include extra properties and methods which are not defined in the interface. But this employee class is implementing from the user interface. So it must provide the implementation for all the members of the user interface. So in this example, the employee class must have a first name and age property, and it must have to provide an implementation of getData method. Now, if we talk on the properties of interface, we have seen read-only property as well as optional property. Now, let's understand the third property, that is extends. So, as I mentioned earlier, in TypeScript, interfaces can inherit from other interfaces, extending their properties and maintaining existing ones. Like here, I'll create new interface with name user1, and which extends existing interface, that is user extends user interface. Now the user1 interface automatically inherits all properties and methods from the user interface. Additionally, user1 can include extra properties and methods, like here I can add one more property with name address of type string. User1 is extending the user interface, but an interface can extend one or multiple existing interfaces separated by comma. For example, here I'll create one more interface with name user2, and I'll delete this extend from here. And now this user2 interface can extend user1 interface as well as user interface separated by comma. So in this case, the user2 interface inherits all the properties and methods from the user and user1 interface. And also user2 interface can include extra properties and methods. Like here, I'll declare one more method with name getName, and this method will return a value of type string. Now, if the employee class implements the user2 interface instead of user interface, so in this case, employee class must implement all members of user, user1 and user2 interfaces, since user2 interface extends both user1 and user. So as of now, we have implemented the first name and age property inside this employee class, and also we have implemented the getData method. But now we need to define this address property as well as we need to implement this getName method inside this employee class. Okay. So now I'll add the address property to the employee class constructor. Here, public address of type string, and I need to implement the getName method here. GetName, and this method return the value of type string. So here return, I'll use template literals. This is first name dollar inside curly bracket first name. So now we have implemented all the members of this user, user1 and user2 interface inside employee class. And remember, interface can extend one or multiple interfaces like this. Similarly, class can implement one or more existing interfaces. It means this employee class currently implements the user to interface. Additionally, we can implement multiple interfaces for the employee class by specifying the interface names separated by commas. Like here, I can write user, comma user1, comma user2, comma user3, etc. But in this case, we can also implement the user3 interface, which would require the employee class to provide implementations for all members of the user3 interface. Okay, so I'll just do Control Z and we will go with user2 interface only. Okay, so as I said, we cannot create an instance of an interface. Now let's create a employee class object and run these two methods. So here var emp equals to new employee. And this employee class will expect four arguments. First is ID of type number. Second is first name, John. Third is age, 20, comma. Fourth is address, Mumbai. Now let's call these two methods with the help of this object reference variable emp. So inside console.log, I'll call emp.getData method. And this method will print the message, welcome to FED Learning. So let's open terminal and rerun this file. And here you can see we are getting expected output, welcome to FED Learning. Okay. Now let's run the second method, get name. And I'll comment out this line number 26, save the changes and rerun this file. And here you can see an output. This is John, because this getName method will return the message, this is John. We have provided the value of first name is John. Okay. So now let's discuss how interfaces are different from abstract classes, because we can achieve the same thing using abstract class also. And the answer is abstract classes supports both implemented and unimplemented methods and properties, allowing for a mix of concrete implementations and declarations, whereas interfaces strictly contain only declarations. This is the primary difference between abstract classes and interfaces. Okay, so we have seen the example of interface with class as well as with object. And in conclusion, the benefits of using interfaces include improved type checking, enhanced code readability, increased flexibility, and promote reusability. That's all for interfaces. Next topic is advanced types. In TypeScript, under basic data types, we have covered built-in as well as user-defined data types. Now, let's understand advanced types. Advanced type refer to a set of features that enable us to create more complex and flexible type definitions. First, we will see the intersection types. An intersection type combines multiple types into one, which means it creates a new type by combining multiple existing types, and the new type has all features of the existing types. And to combine types, we use the ampersand symbol. Like here, you can see the example type AB equals to type A and type B. It means type AB will have all properties from both type A and type B. Now, let's understand this intersection type with a practical example. So here, inside Visual Studio Code, I'll create a new file with name advanced type. .ts. And here you can see the advanced types.js file has been generated automatically because I have compiled this project in watch mode. So I'll just increase the font. Okay. So we have already covered one concept in TypeScript called as type aliases. And what is the purpose of type aliases? They allow us to create new names for existing types. Like here, we have a string type, but we want to assign a custom name to it. Then we can make use of type alias. Like here, I can assign a new name to this type string with type keyword like this. So now instead of string, I can assign a data type as a name. Like if I create a new variable named first name, and now I can assign the alias name instead of string type like this. Okay, here I need to declare this variable with letter var keyword. Okay, so this is how we can use type alias with variable in TypeScript. So similarly, I can define a type alias with name personal for an object that has two properties, name and age. So here, name of type string and age of type number. And now I'll create a new object with name person. Let person equals to, I'll define the properties name and age as a key value pair. So name is Vivek, comma, age is 25. Now to this person object, I want to assign the type personal. And this personal is a type which is our previously defined type alias. Okay. Now the intersection types means it creates a new type by combining multiple existing types. And the new type has all features of the existing types. Like we have seen the example in the PPT, type AB equals to type A and type B. Okay, so we need to use this ampersand symbol to merge the types. But before that, hope you remember the union type uses the pipe operator like this, and that defines the variable that can hold a value of either type A or type B. Okay, so here this is the example of intersection type, and this is the example of union type. But in this statement, this type AB variable can hold the value of either type A or type B. But in the intersection example, type AB will have all properties from both type A and type B. This is the key difference between union and intersection type. Or we can say union types work like OR logic, where at least one condition must be true. In contrast, intersection types work like AND logic, requiring both conditions to be true. Okay, so let's understand this intersection type with this person object. So here, let me create one more type with name contact. So here, I'll edit this personal name to contact, and here, instead of name, I'll write email, and the second property is mobile number of type number. Now we have two type aliases. One is personal and one is font. And I want to assign both type aliases to the person object. And to achieve this, I'll utilize an intersection type. Okay. So how do we do that? So here I'll create a new type alias named student. And here I'll assign it the intersection of personal and contact. So here I'll write personal ampersand symbol and contact duplicate identifier. Okay, so here I'll use small s. Now what I'll do, instead of this personal, I can assign this student type to this person object. Okay, now since the person object is of type student, so it will inherit all the properties from both personal as well as contact type. And what are the properties of personal and contact? Personal type is having two properties, name and age, and contact type is having two properties, email and mobile. And we have already defined two properties, name and age, which comes under personal type. Now we need to define the properties which comes under contact type. Okay, so here I'll add email, and the value of email is vivek@gmail.com. And last property is mobile equals to. Okay, now we have added all the properties from both personal and contact type as a key value pairs. And here note that the order of type doesn't matter when combining them. You can define contact properties before personal properties and still it will work. Okay. So this example demonstrated intersection types with type aliases, but they can also be applied to interfaces. And we have already seen why we need interface in TypeScript and how to use the interface. So here we will replace the type keyword with interface and creating the alias name as an interface name. The only other change needed is removing the equal to symbol. That's it. So similarly here also I'll replace the type keyword with interface keyword and I'll remove the equal to symbol. And in this case also the intersection type is working as expected. And one more thing here, if both the interface or type alias have a same property with same name and data type, you only need to define that property once in the object. Like if you have the email property inside personal interface as well, like email of type string, then you don't need to define the email twice in the object because this email property is available in both interfaces with same name and same data type. Okay, so this is all about intersection type, and intersection type combines two or more types to create a new type that has all properties of the existing types. Now let's understand the second type, that is type guards. Basically, type guards are used to narrow down the type of a variable within a specific block of code, and it shows how you should deal with data types while writing the code. So let's understand type guards with type of and instance of operator. So here I'll comment out all this code. Here I'll write down the comment intersection type. And now let's write the example of type guards. And here first we'll see the type guard example with type of operator, and then we will see with instance of operator. Okay. So under type of operator, I'll create one function with name test, and here I'll pass one parameter with name x of type string as well as number, and here I'll use type symbol, and this is called as union type. So in this scenario, if we assume this x is a string and we want to use two uppercase function with it, like x dot to uppercase semicolon. But here we are getting an error. Property to uppercase does not exist on type string or number. So to resolve this error, we need to add additional validations to narrow down the type of x, assuming our code is more precise. Okay, so here I'll write if condition, and in condition I'll use type of operator, like type of x equals to string. Then I'll move this statement inside if condition. Okay, now you can see error has gone. I'll add the second condition, that is type of x equals to number, and here I'll use x dot to fixed method without an error. Okay, and here instead of this else if block, you can also write this x dot to fixed method inside else block. Okay, so this is how we can make use of type guard in TypeScript. Now let's explore another type guard example, that is instance of type guard. So here I'll declare one class with name parent and body of the class. And after that I'll declare one more class with name child, and this child class wants to extend the parent class. And inside this child class, I'll write one method with name getData, and inside this method, I'll log one message. This is child class method. Okay. Now after this, I'll create one function here with name info, and here I'll pass one parameter p, and I'll assign the type of this parameter p is parent, this parent class. Okay. Now we have written the code like child class is extending parent class, which means now a child class can access all the members from parent class. So once I create an instance of a child class with the help of object preference variable, we can access the properties or we can access the all members from parent class. So now inside this function, I want to call this get data method. So here what I'll do, I'll just write p dot get data. That's it. But here you can see we are getting an error. Property get data does not exist on type parent. So in order to resolve this error, we can make use of instance of operator. So here I'll add one if condition, and the condition is p is instance of child. Then I'll invoke this get data method. And now you can see error has gone. Okay. So this is how we can make use of type of and instance of operators to implement type guards in the conditional block. And I repeat, type guards are a powerful feature in TypeScript that allow you to narrow down the type of variable within a specific block of code, and they provide a way to refine the type of a value based on certain conditions, making your code more expressive, maintainable, and type safe. Okay. Now let's understand the third type, that is type assertion. We have already covered type assertions while learning basic data types in TypeScript. But since the type assertion comes under advanced type, we will quickly understand this concept with a practical example. So the type assertion is a way to manually specify a variable's type in TypeScript, overriding any incorrect assumptions made by the compiler. And the TypeScript provides two ways to do type assertion. First is using angular bracket and second is using as keyword. Let's understand this with practical example. So here, this is the example of type assertion. Here I'll create one variable with name sample, and I'll assign a string value, this TypeScript. Okay. So this sample is a variable name of type any, and I have assigned the value TypeScript to this sample variable. Now let's create another variable with name language, and now I want to assign the same value to the language variable as a sample, that is TypeScript. So in this case, I can use type assertion, inform the compiler about the correct data type of the value. And as I said, TypeScript support two types of type assertions. First is using angular bracket. So here I'll add string inside angular bracket, and then I'll use this variable name sample. So in this case, I have assigned the same TypeScript value to this language variable using angular bracket. So here, if I log this language with type of operator, and if I run this file, ls, and I'll run this file with command node space advanced type as advanced types. And here you can see output string, because this value is a type of string. Okay. Now let's assign the same value using as keyword. So here, instead of this, we can use as keyword sample as and type string. That's it. So the type assertion allows you to set the type of value and tell the compiler not to infer it. Okay. So we have now covered both the theoretical and practical aspects of intersections, type guards, and type assertions.
Now let's move on to the generics. What are generics? Generics enable the creation of reusable code that can handle diverse data types. This means we can write reusable code for various data types using TypeScript generics. And they act as type placeholders, enabling flexible functions, classes, and interfaces that can adapt to various input types. And when implemented, generic types are replaced with specific ones. This ensures type safety and flexibility. Now, let's explore this concept with a few examples. And to do this, I'll create a new file in Visual Studio Code called generics.ts. And I have compiled this project in watch mode, which is why the generics.js file has also been created. Okay, so here let's write the example of generics with function, interface and class. First, we will see the example with function. Okay, so here I'll create one function with name identity and I'll pass one parameter with name arg of type string. And this identity function will return a value of type string. And inside function, I want to return the value of arg. And if I call this function inside console.log identity, here I'll pass string value fed learning. So this is how we can write parameterized function, and at the time of invoking the same function, we used to pass the value for this arg parameter. So since this arg parameter is of type string, I have passed the string value. But here, if I pass the number instead of string, I am getting an error. Argument of type number is not assignable to parameter of type string. So here, what I can do? I can just replace this string with number. So in that case, I'm not getting an error with number argument. So in order to pass the different data type value to the same function, what we can do? We can use any data type instead of string or number. So in that case, we can pass any data type value to the same function. But the any data type sacrifices type safety. Essentially, this any data type tells the compiler to turn off type checking for variables and functions. And it will allow us to assign any value to a variable and call any function or method on it without raising compiler errors. So, if you want to maintain type safety, consider utilizing generics while writing TypeScript code. So to use generics, instead of any type, we can write any letter like ABC. I'll write T as a type parameters. So this T is called as type parameter. So here also I'll update this any with letter T and then provide the same type parameter in angular bracket after the function name here. So this is the syntax of generics. We need to provide the letter as a type parameter and same letter we need to provide inside angular bracket after the function name. And you can see in this case also we can pass any type value to the same function. So here I can pass the boolean value like true. I can pass the array like 1, 2, 3, 4. Also I can pass the object like age equals to 20. So this is how, with the help of generics, we can pass in various types of data and create reusable code to handle different inputs. And this type parameter works as a placeholder of our data type. If you pass string value, this type parameter update with string. If you pass number, then this will update with number. If you pass boolean, it will update with boolean, etc. And one more thing to keep in mind is that generics are not available in JavaScript. When this TypeScript code is compiled to JavaScript, the generic syntax is lost. However, generics are a powerful feature in TypeScript that make our code type safe. So here you can see that the JavaScript file does not contain any generic syntax like interface. Okay. So if I run this file, you can see the output. So I'll run this file with command node space generics. Here you can see the output of type string, number, boolean, array and object. Okay. Now let's see the example of generics with interface. So here quickly I'll create one interface with interface keyword and then interface name, employee, and inside interface I'll write two properties. ID of type any. This time I'll use any data type. And next property is address of type any. And after this I'll create one object with name emp1 of type this employee interface equals to body of the object. Since this object is of type employee, we need to define these two properties inside this emp object as key value pair. So ID is of type number, so that is why I'll pass number value. And next address, I'll pass value as a string. Navi Mumbai. Okay, so this is how I have created one interface, and after that I have passed the interface name as a type of this emp1 object, and I have defined these two properties inside emp1. So now, as I discussed earlier, any data type doesn't ensure type safety. So now let's replace it with generics. But in this case, ID is a number and address is a string. So we will use two parameters, that is T for ID, or we can say number, and U for string or this address. Okay. And after this interface name, we need to provide these two type parameter inside angular bracket. So here I'll pass T comma U. So this is how we have converted this interface of type any to generics. Now, in order to use the same interface, here we need to pass the data types as per the data. So here I want to pass the number type data to this ID. For T, I'll pass number, and for U, I'll pass string. So in this case, this T represent number and this U represent string. And even if you want the ID to be string, it will still work. Like here, I'll create one more object with name employee2, and here instead of number, I'll pass string. And here we need to pass string value. So this is how we can reuse the same interface for different data types. Okay. So now last we'll see the example of generics with class. So here I'll create one class with name container, and inside class I'll declare one property with name value of type string. Next I'll create constructor with one parameter val of type string, and inside constructor I'll assign this parameter value to class level variable. And we can access class level variable with this keyword, this dot value equals to val. Okay, so since class can contain properties, methods, and constructor, now I'll create one method with name get value, and this method will return a value of type string, and inside this method I'll return the class level variable, that is this dot value. Now to execute this get value method, I must first create an instance of the container class. So here I'll create an instance like const container equals to new container. And this constructor is holding one parameter, so this will expect one argument of type string. So here I'll pass fd learning. But here if I pass the argument of type number, then I am getting an error. So currently I can pass only string values due to string type constraint. So to make type generic, we can pass a type parameter like T. So here instead of string, I'll write T. And then after this class name, I need to provide the same type parameter inside angular bracket. Now I can pass any type argument to this class. Like I can pass number, I can pass true or false. I can pass array 1, 2, 3, 4. Also, I can pass object. So with generics, we don't have any data type constraint. So we have seen the generic concept with function, with interface, and with class. And the difference between generics and any is the key distinction between any and this T later inside angular bracket lies in their type constraints. Any represents a type that accepts any value, whereas this T later inside angular bracket is a generic type parameter that can be replaced with a specific type at runtime, ensuring robust type safety. Whenever possible, prefer generics over any to leverage enhanced type safety and compile time error detection, reducing runtime errors. In short, generic type keeps type information, whereas any is a type that can be anything. So we have studied most of the key TypeScript concepts. For a quick summary, I have listed all the topics covered in this video. Still, if you feel any important aspects were missed, please share your feedback in the comments below. I'll try to create a separate video on it. Also, if you want the source code, let me know in the comments below and I'll provide the GitHub link. Okay, and one more request, as I am a new creator on YouTube, I have invested a lot of time and effort in creating a comprehensive video on TypeScript. So kindly help me by liking, sharing, and subscribing to FED Learning. Your engagement inspires me to create more valuable content. Thank you. Bye bye.